or something like that. It can help us to create art, music, and can also improve self-driving cars so that one day it can be more reliable and more safe. All right. That's basically the idea. I want to talk more about art, and we have proposed recently an exciting data set. It's a collaboration between Stanford, Polytechnique, and KAUST. The CFX executed by a student from Stanford, a student from KAUST, and this was mainly executed while I was visiting Stanford. And the idea is actually, some part of it is also connected to psychology of emotions. And one of the key inspiring books for us was Lisa Barrett's book on how emotions are made. And it has this nice picture and asked people, do you feel anything about this bunch of pictures? And maybe nobody felt anything, but if you get back the color of that image, now you see it's a snake and it can cause a harm, and then this might construct an emotion like fear, right? So our recognition or understanding of the visual object of our emotional response towards the image is also connected to our perceptions towards it, right? And that inspired us to study this a little bit further. And we propose a dataset called Artemis, Affective Language for Visual Art. This paper, we presented it at CVPR, Computer Vision Path Recognition Conference, which is the top computer science journal, last June. And it has more than 455,000 language utterances collected on the WikiArt dataset, which is composed of 80,000 images, right? And the key difference between this and the others are basically the emotional component. So existing datasets like COCO, this is a very seminal work, and it have made a huge impact. But it's an objective. Like, let's say both the top row and bottom row talk about birds, but look at the difference. The bottom row talks about the bird. Say a bird is sitting on the table drinking a cup of tea. A small bird sits on the top of a book page. Small birds walking on the grass next to the body of water, etc. So that's describe objectively what's happening in the image, but it doesn't have any emotional aspect. In Artemis, we have something like this painting makes its own paintings, because paintings are more likely to construct emotional responses. This makes me feel like birds are flying on top of my head. This is a picture of a bird that gives me hope. The pale color palette of the water painting is very relaxing, and I can imagine myself sitting by the water listening to the birds. So it kind of you can see significant increase in emotional aspect when you describe a painting versus in the new dataset versus the previous one, and they are of a similar scale. So this 455,000 utterances is of a similar scale to COCO captions dataset. And the reason why we have this response is that we got inspired by psychology of emotions to design the actual interface where we
wissen, welchem Niveau da die Vorträge sind, wo ich morgen hin muss.
So we ask people to select an emotion, like the positive emotions are on the left and negative emotions are on the right, and we give the actual emoji for that, so that it helps people to self-recognize the emotion. Because Lisa said that when you have an actual face that stereotypes this emotion and people are familiar with, the task of self-recognizing what they feel about this painting becomes easier, because it will become more like, do I feel more like this emoji, right? That I fully recognize what it means. And then after they select the emotion, the language description that we collect from them is an explanation why they pick that particular emotion. And then we have this histogram of the emotions. So these are the histogram distribution of different emotions that we collected from people, from the 455,000 utterances. And you can see that I think it's more that the case that we have more positive emotion than negative ones. Like you have more amusement, contentment, excitement than anger, disgust, fear, etc. So the people are more like positive about the paintings than being negative. There could be a little bit of bias. So, and these are some preliminary results that we showed in the paper, and you can see the model have an ability to describe, let's say, Starry Night painting by like Banco, that by the blue and white. It's out the feeling that was produced by, in this case, the blue and white. The colors of this painting makes me feel like I'm at a dream. So these are automatically generated captions given that particular painting. So this shows that actually we can also build emotions that have a sense of describing emotional aspects of it, and we can build, I would say, like some of this to help, I would say, and interact with, let's say, blind people, so that they may appreciate art more. And then I would say, like more recently, we developed a better method that can kind of model imagination or creation of new art as a walking loss. So mathematically, we build. You can think about it intuitively as a random walk loss, and this random walk loss is trying to start from set of scene, let's say art style. Let's say C1, C2, and C3 are scene art styles, and we want to walk through the gray dots so that we don't land any close to any of the scene classes that we start from. So this is a different way from modeling. As I mentioned earlier, there is scan. We talked about this as a loss function, but another loss function is to model this deviation or model this creativity against art that has been seen by something like imaginative works, which is something we proposed recently. And that loss, interestingly, improved performance on recognizing unseen birds, but also creating, more interestingly, it produces novel arts. And you can see the difference between, let's say, CAN results in 2017 and the imaginative work results, which are built on top of more recent architecture. You can see that the model is capable of producing more interesting stuff, and the quality of the models are better, and they are also different. So this picture, for these two rows, the top part, this 4x4 grid, are all generations of the model, and these two rows shows one of these images and the nearest neighbor paintings in the data set. So this shows that the model created something new, because there is nothing similar to that painting in the existing data set. So so it has some elements of creativity. And the thing here also, that people have emotional reactions towards machine generated art. So on that, only 9% of people don't feel anything about this, but the remaining have diverse emotions, and we can describe some machine generated paintings like this by scar, dark, fear, ghost, etc. And these are just machine generated. Some others are excitement, red, interesting, peace, aoi, white, interesting, mountain, trees. So people can also, it goes actually back from being mainly abstract in Kansas to later being also describing, also generating paintings that describe objects. And these are some comparison that shows that the new model is better than style GAN plus CAN, which is a 4-year-old model now, and it has this sweet balance thing. It generates images that are that are novel, but at the same time are likable. This is novelty, and this is likability. I want to also share the work that was created by like us and DJ and Hannah. Was like our currently GJ is currently an intern. Hannah was also an intern and at KAUST, and started as the head of Stanford Center of Design and Innovation in South Korea. And we created some art works. This one got accepted at the New York Creativity Workshop 2020. And the nice thing is that recently one of these paintings, which is this one, was featured on the New York 2021 as on the cover page. So we're happy for that. A last thing that I want to share is that we also studied Wolfram principle. I think Professor Gamal talked about it last time, and they have these principles, and it has a really nice. We have a very nice paper on this space called The Shape of Art History on the Eyes of a Machine. We extended this a little bit further to analyze this on machine-generated art, and collected Wolfram principle on more than 1,000 paintings. And what we wanted to study that is different from existing work is that we tried to understand how this Wolfram principles of art history. I would refer you to Professor Gamal talk, who talked in depth about these principles. But we tried to discover if there are correlations between these Wolfram principles and emotion. And we found, for example, strong correlation between contentment and planar versus recessional dimension of Wolfram. We found also strong correlation between amusement and absolute versus relative clarity. So this was some of the interesting finding. And this paper actually got accepted recently in the International Conference on Competition Creativity. And with that, I want to thank you very much. And then I would be happy to take a question if there's a room for that. And after that, we'll hand over to the rest of the team to cover like an interesting tutorial on style transfer, style can, music can, emo style GAN, and textual art. And thank you for that. Yeah, if you have any questions, please let me know. This is the summary of the talk, and before I go to the next, before we move on to the next section. Right. Thanks everyone for listening. Yeah, please. Do you have?
All right, Shaima, over to you, and you may unmute yourself.
Hello, everyone. Thank you, Professor Mohammed, for an amazing talk. Professor Mohammed had actually given me one class about generative models, and it is what inspired me to get into creative AI and music. So welcome everyone. Today we're going to talk about a number of tutorials about the use of creative AI for visual art and music. Behind me, you can see the artist Sujun Chung. She's a Canadian artist based in New York, and she's a former research fellow at MIT. And she's one of the pioneers in the field of machine-human collaboration. What you can see here, she's collaborating with her own AI robotic arm to generate new art. And hopefully by the end of this tutorial, all of you are going to be able to collaborate with your own machines to create something new, whether it was visual art or music. So here's our team, Isha, DJ, Devansh, myself, Arnab, and Kalish. And today we're going to take you on a very nice, entertaining tutorials. So if you haven't done so already, I would really encourage you to go to our GitHub repository to find the links to the tutorials. I'm actually going to share that link on the chat for you to access the GitHub repository. All right, so here's our roadmap for today. First of all, we're going to start with style transfer by Isha. She's going to present a style transfer where you can move an image from one domain to another. You can see here the beautiful KAUST campus is being transformed into different styles. One of them is the Starry Night painting. Then we're moving to Style Can with Devansh, where you can generate high resolution creative images and paintings in one shot. Later, we're moving to Music Can with me, where we can get in the zone and generate new music, whether it was classical or different types of music. Then we're moving to Arnab, who's going to take over with Emo Style GAN, where you can input an emotion and generate an art or a piece of painting that represents that emotion. For example, the painting in front of you is represented by the emotion anger, and the generative model generated the following painting. Then Kalish is going to present to us text to art, where you can transform any piece of text into a painting or an image. As you can see here, a nice calm day for a city on the water is transformed into the image in front of you. And I honestly think it's a very good representation of that text. At the end, Devansh is going to take the presentation and present image animation, where you can animate any static image or painting into a moving one. Like, for example, here you can see the Mona Lisa is singing. All right, I hand over to you, Isha, to take us on a journey and present to us style transfer.
All right, thank you, Shaima. Can everyone please confirm that you can see my screen?
We can.
Perfect. All right, thank you. So hello, everyone. My name is Isha Khurram. I am a fourth-year undergraduate student at the University of Toronto. I'm studying cognitive science and psychology, and currently I'm interning under Professor Mohammed Al-Husseini at KAUST, the King Abdullah University of Science and Technology. And like Shaima mentioned, my tutorial will be on style transfer. So today you will be learning three main topics. The first one is neural texture synthesis, the second one is neural style transfer, and the third one is something that we like to call fast neural style transfer. And you will be seeing some examples that I generated using a hands-on demo that we will all get to try out at the end of this tutorial. Before we get started, I'd like to quickly make some remarks about a topic that most of us are quite familiar on, which is AI. And we know that artificial intelligence is capable of many things, and it often completes tasks better than humans. For example, artificial intelligence tends to predict the weather more accurately than humans. It tends to derive the answer to complex questions more faster than humans, and it can even perform surgery more precisely than humans. So instead of focusing on the many areas and things that AI can do better than humans, it may be more useful to focus on the things which, in the areas in which AI is yet to dominate. And one of these fields is creativity. It's easy for artificial intelligence to come up with something novel just randomly, but it's very difficult for it to come up with something that is novel, unexpected, and useful. So let's go ahead and take a look at some of the ways that AI is currently being used in creative fields, such as the visual arts. So the first topic that we're going to be covering today, like mentioned earlier, is neural texture synthesis. And before I move on, I'd like to give credit to Justin Johnson. I am borrowing his slides for the next couple of slides. So the first thing I'd like to say is that the essence of neural texture synthesis is basically captured well in this question on the slide here, which is given a sample patch of some texture, can we generate a bigger image of the same texture? So you can see over here, this is an input of a small image of a texture, and the output of neural texture synthesis aims to basically generate this at a larger scale using the same texture. And in order to understand neural texture synthesis, we need to understand something called a gram matrix, which is basically how closely features are correlated with each other. It serves as a descriptor that tells us which features tend to co-occur at different positions in an image, but it importantly throws away the spatial structure of the input image, and that's very important to remember. We can perform texture synthesis using neural networks by trying to match the gram matrix of a target image using something that we like to call gradient ascent. Now, I understand that this is a text-heavy slide, but please bear with me. I'll go over all these steps quite briefly, but it'll give you a good understanding of how neural texture synthesis is actually done. The first step is to pre-train a convoluted neural network on ImageNet or any database of your liking. Then you will have a target texture image from which a new image will eventually be generated. The third step is to run the target image through the neural network and compute the gram matrices, which is what we talked about in the previous slide, for each layer of the neural network. The fourth step is to initialize the generated image from scratch, and that's what it means over here by random noise. The fifth step is to run the generated image through the same neural network and compute the gram matrices for each layer of the neural network again. And that's basically what I said in the third step, so we're pretty much repeating that. The sixth step that I like to mention is that the scalar loss function is basically the weighted sum of the Euclidean distances between the ground matrices of the original and then the generated texture images. The seventh step is to backpropagate to get the gradient of the loss with respect to the image that is being generated. The eighth step is to make a gradient step on the image that we are generating, and the last step is to basically repeat this procedure, and the hope is to generate an image that has the same ground matrices as the original image. All right, so it turns out that this procedure actually works really well. So neural texture synthesis by matching ground matrices allows us to generate and synthesize novel images that match the same texture as the input image while still looking a little bit different in terms of spatial structure. So if you take a look at the top row over here, you will see several images that we will call input images or starting images. And the bottom rows over here are images that are being generated by matching the ground matrices at different layers of the neural network. So each row represents a different layer. And if we generate images that match the ground matrices at a lower layer, as shown here, we tend to capture low-level patches of color. But as we additionally match the ground matrices from higher levels of the neural network, we tend to synthesize novel images that match the overall texture of the input image, but again, they have different spatial structures. All right, so let's go ahead and apply the theory that we learned right now about texture synthesis to neural style transfer. In simple words, neural style transfer is a class of software algorithms that manipulate digital images to adopt the appearance or visual style of another image. On this slide over here, you can see this a content image, which is a photo of these buildings. We can see a style image, which is Vincent van Gogh's infamous Starry Night, and then we see an an output image. So if we want to apply the theory that we just went over, we can basically describe neural style transfer as generating an image that matches a feature of the content image and that matches the ground matrices of the style image. And that is exactly what you see over here in the output. So using gradient ascent, we can match both these things to generate a novel image that once again matches the features of the content image and the ground matrices of the style image. So because we are using a gradient ascent approach, we will start with an image that has a random initialization, and this image is shown on the top left corner over here. And then we will perform gradual and gradient steps over time that will again gradually change the image to generate a novel image that matches, and I'll reiterate myself again because this is a key point, but it will match the features of the content image and the ground matrices of the style image. And this image over here, again, courtesy to Justin Johnson, basically shows the progress of gradient ascent over many iterations as we eventually come to and converge to a final output that you can see in the bottom right corner here. And this bottom right image is exactly the same image that you see in the previous slide as the output. All right, so while this is very cool, very interesting, and innovative, there are some drawbacks to neural style transfer, and one of them is that it's very slow and requires a lot of GPU. So a solution that we tend to use and tend to work around is something that we like to call fast neural style transfer. And fast neural style transfer is similar to neural style transfer, but there is one significant difference, and you can tell it by in the name of the title, is that there is a feed-forward network that is involved, and a feed-forward network basically allows the input of a content image and the output of a stylized result. So when we're training with a fast neural style transfer, the training may take some time, and that's really important to know. But after the training, all we have to do is break away this feed-forward network and simply stylize images for us in a single forward pass. And that is exactly what the demo that I will be showing you today does. Our demo is on fast neural style transfer, and I have to give courtesy to Logan Engstrom from MIT, who is currently pursuing his PhD in machine learning, as I am borrowing his pre-trained network. And his pre-trained network allows us to take any style from 6 infamous paintings, which I'll go over in the next couple of slides, and apply them to any photo that you'd like in a matter of seconds. And note that that's in a matter of seconds is bolded on this slide because that's basically what fast neurostyle transfer does. It allows us to work in real time. So the first style that we will be able to experiment with and that Angstrom pre-trained his network with is called the shipwreck, which was made by Joseph Mallard William Turner in 1805. And over here you can see that the style image is again the shipwreck that was pre-trained. The content image I chose for this example is the picture of a Titanic, just because I thought it was appropriate for the style image. And this is the output that was generated. And over here you can see in this GIF that I'm actually using the demo that you'll be able to play around with in a couple of moments to generate this example. And all the examples you'll see on the next couple of slides were used and generated with the demo. The next painting that he pre-trained his network with was called The Great Wave of Kanagawa by Katsushika Hokusai in 1831. Apologies if I mispronounced the name. And I took an image of a modern day surfer, and you can see the compare and contrast. I thought it would be interesting because this style image, this painting was made over 190 years ago, and it's nice to see how it compares to a modern day photo. The third image is, or the third painting or style is called The Scream by Edvard Munch. It was made in 1893. Same procedure, here's a content image, and you can see the Scream style being applied to this content image. The fourth style is called Udni by Francis Picabia. It was made in 1913. I chose a very interesting and funky looking building to match the aesthetic of the style image, and it generated this output over here. The fifth style is called Amused by the infamous Pablo Picasso. It was generated in 1935. It was made in 1935. And here I took an innocent child's hand drawing, and if you apply Pablo Picasso's Muse style on top of it, it generates this output that if Pablo Picasso himself made it, would probably have sold for millions of dollars. And the last style is called The Rain Princess. It was made by Leonid Afremov in 2014, so it's a relatively more recent piece of art. And here I took Vincent van Gogh's Starry Night, just because I thought the textures looked quite similar, and you can see the output that it generated. And again, all the examples that you are seeing were generated by me using the demo that we are about to see. This is the Kaust beacon. This is a landmark that everyone recognizes Kaust by, and I'm just trying to make the point that this works with architecture. This also works with animals here, as you can see with this very cute kitten. It also works with humans and as well as nature. So the point that I'm trying to get across is that you can take literally any photo and completely transform the way that it looks by applying a style of one of your favorite artists. So now I'm actually going to invite you, if you can and you have access to a laptop, to go ahead and head over to our GitHub repository like Shaima mentioned earlier. And if you click on the link, it should lead you to this page. And these are all the links to the demos that will be shown in today's tutorial. And of course, you can click on mine over here called Style Transfer, and it should lead you to a Google Colab notebook as such. And I'll just briefly go over the basics of a Google Colab notebook for those of you who are new to it or have never used it before, because this is also my first time working with it. And it's actually very simple, so there's no need to get a little worried about it because it's very straightforward. So basically, a Google Colab notebook consists of many cells. There are two types of cells, a text cell, which you can see over here, and some code cells. And code cells contain executable code that when you run it using this play button over here, you will generate an output. So now I'm actually going to go ahead and ask you all to, if you're following along, to press play and run the first 4 cells that you see over here. Let me just go ahead and, yes. So we're going to go ahead and run the first 4 code cells. And now I'm going to ask you to upload 2 things. So I'm going to invite you to now to press on this file icon over here, and you should see 2 folders. The first folder is called Fast Style Transfer, and the second one is called Sample Data. When you press on Fast Style Transfer, you should see a series of folders and some files. And I'm now asking you to go ahead and upload the train network to the checkpoint file over here. And you can access the train network on this Google Drive link over here. So once you click on it, you'll see the 6 different paintings that I went over in the presentation. And I went ahead and, already uploaded all 6 of these train networks in the interest of time, because it does take a while to upload. But again, all you have to do is download perhaps 1 or 2 in the interest of time, and upload them to the checkpoint folder by pressing these 3 dots over here. You click upload, and then you can locate them on your computer. And the next thing that I'm going to ask you to upload is your sample photos. So if you go to My Data and Train, I've already put some sample photos that you can access over here in this Google Drive folder. These are all the photos that I used in my presentation. As you can see, if you want to use your own photos, please feel free to. Just remember to use PNG or JPEG files, because those work best, and then to rename the file to something very simple, because you'll have to be typing up the file name later. So I went ahead and already did this, and you can see that I have 6 different train networks in my checkpoint folder and 10 different images in my train folder. So now I'm going to go ahead and run the other code cells. And now this is where the demo gets a little bit hands-on. I'm asking you to specify the name of the image file in the first line, and then specify the name of the train network file in the third line. So over here you can see that I have an image in my train data folder called Titanic.png. And let's say I don't want to generate an image of the Titanic. Let's say I want to go ahead and generate an image of a cat. So I'm going to go ahead and locate the picture of the cat that I have. And the title of it is called cat.png. So that's what I'm going to write over here. And let's say I don't want to experiment with the La Muse text style. So instead, I want to try Rain Princess. So that is exactly what I'm going to type word for word. Make sure the spelling is correct. And then you're going to run this code cell and continue running. Run the main function as well. And this is where most of the magic happens, in this code cell over here. And you can go ahead and review and view the original image that you had. So right now it should generate an image of the cat. And by pressing this code cell over here, you can actually see what the cat would look like with the Rain Princess style on top. So as you can see, it's very simple to use. I can go over a very quick example before I hand over the presentation to my colleague. Let's go ahead and see if we want to instead use a picture of, let's say, the beacon from KAUST. And notice that the name of the image is a JPEG file. So I'm going to write the beacon and replace PNG with JPEG. And let's say I don't want to experiment with Rain Princess. Instead, I want to try Rec. So I'm going to go ahead and only run this code cell. You don't have to run anything above, because we haven't touched the code there. Now we're just gonna close this. We're gonna go ahead and run everything. And now you can see right now it still shows a picture of the cat, but when I press this, the picture of the beacon will pop up. And now when you press this code cell, you'll see the beacon with the rec style implemented on top. So as you can see, this was very simple, very straightforward, and I hope you can use this to your advantage during the hackathon. Please feel free to play around with it. And that's about it for me. Thank you everyone for listening. And now I'm going to hand over everything to my colleague, Divyansh, who is going to be covering StyleCan. Divyansh, it's over to you.
Yeah, thank you, Isha, for the beautiful presentation. I'm Divyansh, and I'm a visiting student researcher at KAUST. I've been working with Professor Mohammad El Hosseini for over a year on this domain of creativity and AI. Today, I'm going to talk about a model called StyleCan. So you just saw how to generate images, like when you have 2 images, a source image and a style image, and you want to, take the style of the style image over the source image, right? Or the content image. This requires like 2 images to generate art, some level of, your own thought process, some level of manual work. But what if I don't have time and I just want to create a bunch of art pieces at once? What can I do? So for that, I use StyleCan. Notice that it generates novel images. So we will talk about it. You must be familiar with Can using through the presentation of Professor Mohammed. As he talked about this in the presentation, we will also go over it briefly. So we will learn StyleCan step by step. First, we will learn GANs and its applications. Then we will again go briefly over creative adversarial networks for those who have joined a little bit later. Then we will talk about what StyleGAN is, and then finally we will learn what is a StyleCan, and again demo which you can try live at your own in your own laptop. So what are GANs? GANs is actually a short form for generative adversarial networks. Why generative? Because it learns a generative model. It learns to generate something. It could be an image. It could be a 3D model. It could be a mesh. It could be music. So whenever a model learns to generate something, it's a generative model. Adversarial, because it is trained in an adversarial setting. So we will talk about this very deeply in the upcoming slides. Let's let's go over it now, but we will talk about it more in the upcoming slides. Networks, because of course it uses deep neural networks for its task. It could use on like shallow networks as well, but usually the de facto standard is that GANs are usually very deep networks. Again, these slides and images are taken from several sources, as you can see on the source links on the bottom. So what are generative models? Generative models generate something, as we talked about. These are different from discriminative models, which learns to classify, let's say, a cat or a dog. So if a cat image is passed, it gives us one output, which like, let's say it's a cat. So it is not generating something, it's just giving an inference that, hey, I see a cat in this image. So this is a discriminative model, while generative model on the left is generating bedrooms, real images of bedrooms which do not exist, which are not photographed, but they are generated from a network. So I find GANs pretty fascinating, as they can be really they can generate really good stuff several times. First of all, why do we need such models? It turns out there are several use cases of such models. One such use case is super resolution. So how many times have you run into an issue when you have an image and you want to resize it to put in your presentation, and what you see is a pixelated version of the image after you resize, and it looks something like blurry and doesn't look good in a presentation, right? So what super resolution does is increases the resolution of the image while maintaining the content of the image. So here are two techniques which can do that. First one is SR ResNet, and the second one is SR GAN. So this is this image which needs to be super resolution. It is a blurry image. You can't see much into that. But using a deep neural network called SR GAN or SR ResNet, we can actually do a super resolution on this, and it is looking nice. Although it's resized, but it has also removed these checkerboard artifacts from here. It's created smooth boundaries. And this is another like higher like improved model over SR ResNet, which has created better imagery. As you can see, the water here is like not blurred. It has clear defined structures. And as you can see in the slide, it is pretty close to original. So isn't it like very cool? This is actually this image is actually taken from the paper of SR GAN. So credits to them. Next, we look at one of my favorite models called Pix to Pix. What currently you are seeing here is an example of image translation. What do I mean by image translation? Is given an input image, it will convert it into an something else but different output image. So Pix to Pix is a network which can convert an input black and white image into a colorful image. So there is a complete startup by a person, and he has also open source his repository named Deoldify, which just focuses on this aspect. So this model can do several things actually. It can convert your satellite imageries into like map. It can convert your semantic map into a real image. So this is like just the label of a scene in a city. So it says that these are all cars. This is a road. This is a car, and this is sky, trees, and all that. When it is trained, it can learn to convert this image into this one. It can convert your raw edges of sketch into a real looking handbag, and it can just extend from these sort of things. But what is required for training such models is that it requires a paired imagery. So for each satellite image, there needs to be a satellite image from the same location and a map from that same location so that it can convert. So it is kind of a supervised learning problem where we have both input and output. But this model called CycleGAN can do that in an unpaired fashion. So we do not have images of like paired horses and zebras, paired apple and oranges, but this network called CycleGAN can use those unpaired images and learn to transfer these horses into zebras. I do not know why you would want to do that, but this model can turn an apple into an orange or vice versa. I mean, the idea of this model is so cool. I'm so flabbergasted by this algorithm. One cool example that the authors of this paper have created is converting this horse into a zebra, which looks pretty real to me actually. There are some artifacts though, but it is awesome, right? So again, this GIF image is taken from this repository. I would highly encourage you to go over the sources and really take a deeper look. But one more thing actually, we can also generate sceneries in an interactive fashion. So I define, let's say I want to create a grassland, so I draw a rough sketch and I just add some label to it. I draw water body, I draw sky, and I pass it through my network, and it can actually convert this into a real scenery, and it can also change the time of the day, as you can see in this GIF. Similarly, on the other side, this is actually a model image from NVIDIA SPADE. It's a paper by NVIDIA which specializes in this. They propose a new layer which can do that. I would again highly encourage you to go to this page and have a deeper look. So how does GAN do it? I mean, it's interesting. If we were given this, we would require some time actually to create something from our own imagination. But how do GANs just do it like in few seconds? The answer to this question lies in one of the things which I did not explain earlier, which is adversarial training. So for example, there are two people, this guy who is a forger and this another guy who's detective. But this person both of them are newbies. They do not know, he does not know nothing about detective and his work. He does not know anything about forging. He does only, the thing he can do is like generate something. And this detective The only thing he can do is just do classify whether if what he has seen is a real image or a generated one. So so what initially this both of them are newbies and they do not know anything about it. So this person forger generates something, and the task of detective is to classify whether it is a real art or a fake art. So the only signal the detective gets is that whether he was successful or not. If it is successful, he will like learn more about what real art looks like. When the fake image is passed, the detective classifies it as real or fake. And if the detective is successful, the forger gets to know that. And he has to change something in his, drawing style so that he's able to fool the detective. So these two people are adversaries of each other. They're both trying to fool each other. They're both trying to, outclass each other, right? So that kind of playing a game. And when they do this several times, like they just generate millions of paintings, and detective also classify millions of paintings, and they receive the signal whether they were successful or not. They learn. What they do is actually learn. This person becomes the better at his job. This person becomes better at his job. So this is the beauty of this adversarial training. Like we can take an example of competition. If there's like two highly competitive companies, they're both trying to become better, and as long as they're both trying to become better, they both will grow. We can take example of Messi and Ronaldo. They both try to outclass each other in every game, but they both become so wonderful players, right? So this is something called an adversarial training. So this is a like a layman example, but what actually happens, there are two deep neural networks, which is generator and another one is discriminator. As you can see, the input to generator are just random numbers, and it generates something. Initially, it will just generate something random. And the input to discriminator could be a real art, or a real image or a generated image. If it is real, it should classify it as real. That's the signal that it will get that you were successful. But if the generated image is passed, it should be able to classify it as fake. And the generator also gets to know whether it was successful or not. So in this process, when lots of training steps happens, so for example, if we are training on art data, if it sees lots of art images, and it learns to classify what art images look like. On the other hand, this generator also learns to generate images which looks like actual art. So this is the magic of adversarial training. So now that we know GANs, I will just briefly go over creative adversarial networks, as it was previously covered by our professor in his presentation. So it is actually a paper by him only in 2017, in this paper they use this data set called Wiki Art, which contains 80,000 art pieces, real art pieces, which also has their styles associated with them. So for example, painting, and let's say it's style cubism, or maybe minimalism, realism, something like that. So what the paper says is that traditional GANs are emulative. What do we mean by that? Is that suppose a GAN is learning from, let's say, two types of style, realism and cubism. If it has only seen those two styles, what it will generate will be new, but it will produce from the same style. It will either generate cubism or realism, something like that. But it does not want to be, go beyond those boundaries of the things what it has seen. But we want the generator to be creative and explore spaces beyond the established art styles. So this WikiArt data set contains actually 27 art styles. So the generator will have to learn to go beyond these 27 art styles. So as we talked about, this objective of a GAN model, which is real fake objective. So another objective is added, which is like different for both the models. If a real image is passed into the discriminator, of course, it has to learn to classify it as if it is real art or not real art. It should also be able to classify which art style it belongs to. And if the generated image is passed, the discriminator should be able to classify it as art or not art, but it should get confused while classifying which class it belongs to. As you can see, these two forces, like real fake objective and this ambiguity objective, are two contradictory forces. Because when so for example, for generator, it needs to learn to generate an art which the discriminator classifies that, yeah, this is an art piece. But at the same time, it should say, oh, I don't know what style it belongs to. So this is the objective of the discriminator in this. And using this process, the generator becomes creative as it learns to explore the spaces beyond established art styles. So we covered 2 points. First, GANs. Second, creative adversarial network. Our third step before style GAN is style GAN. So what is style GAN? It is a very advanced version of generative adversarial networks. It has very carefully designed these generator and discriminator networks. And the best of all is that it generates very high quality generations. So to look at some of the generations, to assess some of its quality, these are some of the faces that it has generated. To be honest, I'm surprised how good they are. Believe me or not, these are real cars. When I first, I had a glance over them, I was like, are they real cars? But actually all of them are not real. They are generated. They are not photographed. Again, these are not photographed bedrooms. These are all generated by a style GAN. So let's play a game. I will give you, let's say, few seconds to classify which face is real. Okay, the time is up. Let's look at the results. The right one is real. I'm pretty sure that many of you must have considered this woman to be the real one. I myself confused this woman to be the real one. So, but actually this man was like the real image. This is actually a generated face. This is how how good these style GANs are. This just tells us, right? This example. So it can confuse us, the humans. But there are ways of, of course, going around this and looking for specific patterns that GANs have. But we will not go into that. I would encourage you to go into this website, which is called whichfaceisreal.com, and play it for yourself, right? And see how good are you at classifying real versus fake. So we know style GANs, scans, style GAN. So what if we combine style GAN and the GAN objective? What should we call it? We call it style GAN, right? So let's look at one of the example of style GAN, and I would highly encourage you to again go on this repository here. Oops, yeah. Go on this repository here, click on this demo, and it will take you this page. All right. Yeah. So as you can see, there are some, Isha gave a very beautiful introduction to Google Colab. So I will just start with my demo. So this is first cloning the GitHub repository, which actually contains the architecture of the GANs. So I will run this by clicking on this play button, and it will take some time initially. Okay. So I was running another demo. So it asked me to terminate that. So I will terminate it. And it has, I think, cloned the repository. Okay, I'll have to run it again. So if you get something like that, just click on terminate. As you can see, it is creating some files. This will actually download this repository and put it here in my local disk, which I can access later. At the same time, I will also download a model which we have already pre-trained on StyleCAN objective. I will just refresh this folder. And as you can see, I have the pre-trained model here. I have the style-based GAN PyTorch, the model here, the model description architecture here. I will run some code files so that I'm able to access these as a, libraries. So I'll import some libraries for some, dumping of images to calculate something, import standard math Python libraries. Here is the StyleGAN generator, which I am importing. This is the architecture which I'm importing. I've yet not loaded the trained model. I'm importing some libraries like Torch, which is actually a neural network library. You can use it to train neural networks, and some plotting libraries. As you'll see, it will come handy in plotting the result right here in the notebook. So I'll set the model path, which is this model. This is some latent code size, which is some hyperparameter of the model. So it was trained using 512. So I will have to set it to 512 here. It was trained on 256 sized image. So I will have to set it to 256 sized. The only thing that I can change is how many of them I want to generate. So I'll run this cell. I will generate like 3 rows and 5 columns of notebook, art pieces. And I will just like define some helper functions. Actually, these are functions from this repository. Okay, I did not run this. So I'm getting this torch not defined error. So if you get something like that, just run the import statement and it will import all the libraries for you. Now, when I will run it, it works just fine. So here I'm defining that I want to use the GPU, and I'm defining the style generator, and I'm initializing it with the latent code size. I'm importing the model here, and I'm putting into evaluation mode. Notice that we are not training now, we are just using it to inference. So I'm putting it into evaluation mode. So I'm using the size to compute some hyperparameters of the model. So I'm calling this my helper function to get a variable which will help me in generation. The sample function is actually the generator. It will use this generator architecture which I initialized here to generate n rows and n column of images. And these are just some helper code lines to plot this. So let's see what it generates now. So guys and girls, these are all novel generated images right in front of you. I can run it again, and it will generate again totally brand new images for you at each second. You can use it to do your own thing. Maybe have it printed out and maybe use one of the super resolution technique to, increase the size of the image and have it collage or something. And if you want to generate like thousands of these, you can just run this code cell and it will generate like as many as you want. Just you have to change the number here. So this is as simple as it gets to generate a novel art. So this ends my presentation, and I will hand it over to my colleague Shaima, who will talk about MusicCAN. Over to you, Shaima.
Hello, everyone. Can you hear me?
Yes, we can hear you.
All right. Thank you so much, DJ, for an amazing presentation. Really loved that tutorial. And also, thank you all for sharing your generated images and participating in the tutorials. All right. So today I'm going to be presenting to you MusicCAN, which stands for Music Creative Adversarial Network. Let's look at the outline. First, I'm going to talk about the motivation behind this project. We're going to take a look at the dataset, the network architecture, sigmoid versus hard sigmoid, which is the activation function for the last layer of our model. And then we're going to look at unrolling our CAN and ending up with a demonstration where you can generate your own music. All right, so the motivation. Why are people very interested in generating music? Well, currently it's a very hot topic. A lot of people are trying to understand what makes music sound good and how can we generate new music and learn how to do that. It's a different challenge than natural language processing, as it has other aspects to attend to, like rhythm and polyphony. The data set I used for this project is a set of classical music called MusicNet, where each collection is classified by the name of the composer who had composed this these number of musical pieces, like Beethoven and Mozart. The data set is transformed from MIDI files into images, and you can think of it as a musical note grid. Like, for example, if a pixel was high or is equal to 1, then the musical note at that position is on and you can hear it. Otherwise, if it's 0, then there is no musical note being played at that position. So let's move to the network architecture. You've already learned about the GAN network from DJ and the Professor Muhammad. And now I'm going to give you another explanation of it, or to refresh your memory. This is the CAN network architecture, and it's very similar to that of the GAN network. What you have is a Z vector that is random, passed to the generator. The generator generates a musical piece or a music file and a label. The discriminator always gets as an input a musical file and a label, whether it was coming from the generator or from your dataset. The discriminator then tries to figure out whether this is a real musical piece or a generated musical piece. So here we have your regular GAN loss. And then there's another loss that we're looking at, which is the entropy, where we're trying to make our network creative. What we're trying to do here, we're trying to classify the musical piece. And what we're trying to do, we're trying to look if it fits into one or more label. So in a way, you can think about it, we're trying to maximize the entropy between the classes. So a musical piece, we want the generated musical piece, we would want it to have a class that is either different, we haven't seen it before, or if it falls between two different classes, like it sounds something like Mozart and something like Beethoven in between, you know? That's what the entropy loss is trying to do, and it's trying to promote creativity in the network. So remember I told you we're going to talk about sigmoid versus hard sigmoid? Well, while I was trying to pre-train the model, I looked at the output and I had a lot of gray areas. And gray areas, remember when I talked about the data set, we had either zeros or ones in our data set. So the discriminator can see the zeros and ones. The generator has to generate the zeros and ones to look like the real images. However, with the sigmoid being the last layer or the last activation function in the generator, we end up having values between 0 and 1 most of the time, and some of them are either 0 or 1. What we would like to use is the binary step for our data set. However, the binary step, as y'all know, it's non-differentiable because we have a discontinuity here. So the hard sigmoid, in my opinion, worked better because it has more probability of giving you zeros or ones and less probability of giving you other numbers in between, giving us the gray areas. And this gives the generator a way or a help to create images that can fool the discriminator. All right, now let's talk about unrolling our CAN. So before we learn about how to unroll CANs, let's understand what unrolling helps with. What problem does it solve? So on the far left, right, you can see the targets. The targets here are our data set. You can think of them as our data set that we would want to generate. And the outputs here are coming from generators. The second row shows a normal generator. This generator, whenever it tries to generate sampled files or images, it's always generating one mode that falls within the target. For example, here, it's focusing on this mode. And when it does that, it is still being rewarded. It is still doing good and it's still beating the discriminator because it is generating something that is within our real data. However, it is not capturing the full distribution, and it's not mimicking the distribution of our data set. When we unroll our generator or our model, you can see in the first row here, the model is more capable of generating all the modes. And that's why we call it mode collapse, or the issue is called mode collapse, because it can only generate one mode if it's not unrolled. And unrolling is one way to help stop that issue from happening and represent the same distribution. Another example that can help you understand what I'm talking about is a generator or a model that has been pre-trained on the MNIST dataset. Again, the first row is the unrolled model, and the second row is the regular model. You can see in the regular model, it sometimes or always gets stuck in one of the modes, and that's what we call mode collapse. Why am I applying this to the music generation or the music can? The music generation model. That is because I've been facing a lot of problems with the generator generating black images. And that is because when it generates black images, the discriminator thinks it's real music. But I don't want that to happen because then I'm not having any music to listen to. And that's how unrolling helps. But how does it work? What you want to do is you want to train regularly, like you do with any GAN or CAN model. But you can choose your unrolling steps. And what that does is when you generate the new generator, or when you train the new generator and the new discriminator, what you want to do is back up the discriminator. This way, your generator has look-aheads or can see the future of what the discriminator will look like. And the discriminator is always behind. That helps us from having a very well discriminator or a very strong discriminator so that the generator can catch up and figure out what to do before it collapses into one mode and cannot produce any more results. All right. So enough of the theory, let's move to the demo. I will show you now how to create your own music and try both hard sigmoid and sigmoid activation functions to figure out which one you like best. So you're not an expert musician, huh? No problem, we've got you covered. Please go to your to the GitHub repository and find the Google Colab notebook. We've already shared that on the chat, and you can also find it on our dev post. Okay, now I will share with you my Google Colab. Okay, can you see my Google Colab?
Yep.
All right.
Yes.
So in the first cell, I'm going to load some libraries. And because I'm mounting to my G drive, as Isha had shown you before, it might ask me to give it an access permission. So you can all follow along, and if you have any questions, please let me know. I can help. So here I'm loading some libraries and cloning my repository that contains the pre-trained models. And also it contains some images and data sets that you can use to train your own model. Okay. I want you to check that you have 1.9 PyTorch version. Here, I'm previewing some of the data set, some of the images, and they are MIDI files that have been converted into images. You can go and visit this Wikipedia page to learn more about MIDI, which stands for Musical Instrument Digital Interface. In this cell, I'm initializing the generator and the discriminator. Also, if you're not very familiar with this type of cell, you can click on show code to visualize the code or just read the text. Then I'm loading a pre-trained model. It's unrolled, but it uses Sigmoid. In this cell, here is where you can experiment with generating music. When you click on the cell or when you run the cell, you're always going to get a new generated music. If you don't like it, you can generate it again. Okay, we can listen to this musical piece. All right. And if you like your musical piece, you can download it. Now let's look at the pre-trained model with hard sigmoid. In my opinion, I think hard sigmoid does a better job, but it's up to you to choose which one you like. All right, let's listen to it together. Okay, and then the rest of the cells are for you to pre-train your own or to train your own model. Here I'm setting some hyperparameters, loading some all of the images I have, and you can experiment with them and train. So an idea for you to try, you can also change the data set from the classical music data set into different types of music. Like you can, for example, mash up some Arabic music with classical music and find out what you can generate. All right. Okay, so thank you for listening to my presentation. And now we're going to have a 10-minute break. If you have any questions, you can send something in the chat. I'll be here.
Let's thank you, Chaima, and everyone for covering these exciting demos on style transfer, style can, and music can. Thank you for that. Let me suggest, for interest of time, maybe suggest 5-minute break and then come back because we're running a little bit behind. So. Okay. Yeah, feel free to take a break, drink some water, and we have more three exciting demos to go on Style-GAN, textual art, and image animation. Thanks everyone. So let's do 5-minute break. Thanks.
You're welcome. All right. Welcome back, everyone. Our timer just finished. Okay, now I would hand over the presentation to Arnab, where he will be showing us emo style GAN. Arnab, are you there?
Yep, I'm ready.
Okay, the
Okay,
floor is yours.
Here we go, sure. 1 second. Hyperlink, there we go. Okay. So emotion style GAN, conditional generation of visual art. By using our previous knowledge of style GAN, emo style GAN uses style GAN 2, which is an iteration of the style GAN which Divyansh talked about, which comes with adaptive discriminator augmentation. It uses the Artemis dataset, which is an extension of the WikiArt dataset for training with conditional classification for these 8 specific emotions. So this dataset allows us to generate images with amusement, anger, awe, contentment, disgust, excitement, fear, and sadness. So how does StyleGAN 2 work? As we can see here with this diagram, this is how StyleGAN 1 worked, the previous iteration. It would take the mean and the standard deviation of both of the inputs and the outputs to create and put them inside a style block by taking our real to generate our fake real and fake images with our descriptors. However, StyleGAN 2 instead of using mean and standard deviation, just uses standard deviation and allows for analog inputs as well as digital inputs and digital outputs, analog outputs. By putting the inputs and the outputs all into the style block instead of being separated from outside the style block. It also allows for weight demodulation, which allows for weighted pathways for the generation of the images to preemptively generate, preemptively force the code to guess which image would be the best when trying to fake the detective, as Divyansh put in his example. So what is adaptive discriminator augmentation? It is a technique created by NVIDIA to allow smaller data sets to still create accurate images. As we can see here, this is from the NVIDIA Labs GitHub for StyleGAN 2 ADA for PyTorch, and allows us to use this cat by allowing for small data sets to create images such as the cats here with the discriminators and the generators, with the augmentations, as we can see here from this diagram. The Artemis dataset is an extension of the WikiArt dataset, as I've stated before, which comes with emotion labels for conditional training. It comes with emotions, comes with a CSV like this, which comes with a painting name such as Alagoma, in November from 1935, created by Jackson. And we can see by A.Y. Jackson, and we can see this image here that I've highlighted. We can see the same thing here with Jackson Barnes, 1926. Here is, while training, here is the fake artwork collage generated by the Artemis dataset. Each of these 480 images inside this collage has been generated by the AI and is not, and is a fake image. So, conditional training. This AI model has been trained with conditional text, which allows us to generate images based on the 8 specific emotions, with a different image being generated at each moment. For example, we see here we have amusement, anger, awe, contentment, disgust, excitement, fear, and sadness. I'll be opening these up more to show examples between each. So when we put it into the code, where we want to generate the emotion of excitement, the code generates an image like this, which has a jumble of elements inside the image, which creates excitement as it's not really contained. However, fear, we can see, is more from the portrait, much more darker colors, and from the facial expressions, we can see the eyes are bigger and the mouth is more tight-lipped, which allows for more fear. Here's contentment versus disgust. Contentment, we've got blue skies, some nice trees, and a picnic-like setting. And the person in the image is relaxed and brings to the viewer also contentment. Versus in disgust, as we can see, much more darker background. The lips are much more frowning. The eyes are much more slightly small, squinting, and the body language is leaned backward as if they're repulsed. And we have the same thing here for amusement and sadness. There isn't much of a difference between amusement and sadness, which is, I figure, a problem with the AI model that I've trained. However, we can see from amusement, well, it turns out these images are in the wrong way. Here that I've highlighted, which I'm circling around my mouse right now, is amusement. You can see this from the mouth being upturned slightly, lips are slightly upwards, eyes are more open, and the person is enjoying and it's amusing. The person in the photo is finding whatever they're looking at amusing. However, for sadness, as you can see, the eyes are much more droopy. They're in more of an angle. And the mouth is much more tight-lipped again, and much more close together, and putting pressure on top of the two lips, which creates more of a sadness, which forces us to feel sad. Now we have the demo and hands-on. If you would like to visit the collab, which was on the GitHub repo and the README, we can first set up environments and variables. I hope that it should be set up for you. However, if it is not, I'm sorry, but you'll have to wait several minutes just to install PyTorch. StyleGAN 2 does not work with PyTorch, the latest version of PyTorch, which is 1.9, which is why we have to install 1.8.1. If you'd like to run that now, while I would explain to the code, that is fine. That'll be helpful. So here we have, I've already pre-installed it here in preparation for this event. So first we have an import of StyleGAN 2 ADAs from their GitHub, from cloning from this line right here. This cloning allows us to use their custom Torch utils, which connects with CUDA and their custom CUDA code, which allows us to generate and train the AI model. As we can see here, when we generate, we have sys.path, and we have pulled in, so that allows us to import stuff like legacy and DNNL-lib, which was written by NVIDIA. And we also have this dictionary right here. This is just so when you type amusement in the generation code below, it gives the class. So this is the conditional training of the AI model. It uses, of a class 0, it is amusement. For a class of 1, it is anger. We can see this with the CV from the data set right here. It has got amusement, anger, awe, contentment, disgust, excitement, fear, and sadness. And we can see that in the AI, we use something called data set, labels file, which is called dataset.json. And it was mapped as this, as the amusement column as 0, anger as 1, awe as 2, and so on. And that is just mapped to here. And allows you to write as a string, let's say sadness, and it'll just automatically map just to make your life easier. So we import from Google Drive the network snapshot here, this network for the AI trained model, which can be used to generate. Then we just have some ranges. This is just which seed you would like to use. I have set here seed 10 because it has very nice portraits to show the facial expressions. However, you've got access to 480 seeds because each seed is an image from the collage right here, and there's 480 images in this collage. So you can generate up to 480 seeds, and that gives you a large range of images to mess around with. So here we have the generate function, where we're using CUDA and the custom code written by NVIDIA to create images here, which can be found in image generation in the file section. That is also labeled with what seed and the name of what emotion. So now you can generate your image. So here we import matplotlib for you to be able to see the images here that you have generated. We give it a truncation because this is a pickled file, which means its data is extremely condensed, and the truncation allows the code to kind of unpack the model to be able to use it. So, and I also have a few pre-generated images as you wait using C27, which generated images such as this for sadness, this for anger, because a lot of red anger kind of looks like blood. I don't know why, and amusement here, as we can see. And that's about it. I'd like to now hand it off to Kalishbek for text to art.
Hi guys, can you see my screen?
Yep.
So thank you, Arna, for your amazing work. And hi everyone, my name is Kilic. I am a PhD student at the King Abdullah University of Science and Technology under the supervision of Professor El Hosseini. And thank you, Arna. Previously, you explained, introduced your cool work, how to generate art images given conditional, some emotional labels. Now let's imagine that we want to generate synthesized images conditioned on some textual information. So it can be captions, or it can be a word, or it can be like a poem or some part of a lyric. So my topic will be about this text to art generation. So in general, briefly, to generate images, we need some, of course, as an input, a textual description. Here you can see the mountain seems to be floating in the lake. And we need some text encoder, which helps us to represent the text in a way that that is easier for generative models to understand, analyze, and process this piece of information. And also, of course, is the main model, the generative models, so which is used to generate, synthesize a piece of art. So here you can see if we supply the mountain seems to be floating the lake to text encoder, text encoder will generate text embeddings, and text embeddings will be used for in generative model to generate this kind of beautiful image. Of course, this is hypothetical view, like hypothetical output, but in general, we want this kind of output. So a lot of research have been done in text-to-image area. So one of the examples of state-of-the-art methods was attention GAN. So here we trained the attention GAN model on our Artemis dataset, which was explained by Professor Al-Husseini and Arnab. And here you can see some of its generations. I present here like it's four outputs. First one is the man's tired eyes make him look like he has spent many hours in front of a book. So you can see it generates some like a creepy picture. And as well as like, if you can see a nice, if we give a nice calm day for a city on the water as an input, the generator tries to generate some silhouette of the city, which closely matches to a given textual information, which is like some water and silhouette of the city. And so on January 5th, 2021 of this year, you guys might be familiar with OpenAI. So OpenAI released the model weights and the code for CLIP, which is like trained on really large data set, around 400 million of image and text pairs. And as a consequence of this multimodality training, CLIP can be used to find the text caption that best represents a given image or the most suitable image given a text query. So after OpenAI released the weights there, after OpenAI released their model, there was a boom in AI community, and various hackers, artists, and even like deep learning enthusiasts started to they figured out how to utilize this like powerful model CLIP as a guide, as a natural language steering wheel for various generative models. And this in turn allowed artists to create all sorts of interesting visual art by inputting some text information. So here I will briefly describe like CLIP-based models. This is like a really high level depiction of how CLIP can be used to generate art, because we don't have that much time. So basically we have two models, big GAN, like some generative model. It can be used, it can be any generative model, GANs, like big GAN, SAAI GAN, or VQ GAN, and even Siren. So, and we have a CLIP model. CLIP model just computes embedded similarity measurement. But for that, we need some output from generative model. Generative model tries to generate some image. So this image will be given to a CLIP image embedder, and this embedder will, CLIP image embedder will generate some embeddings. And the textual information will go to CLIP text embedder, and CLIP text embedder will also generate the, tries to map this image embedder, and text embedder tries to map like inputs to the same like project to the same space. So in this way we obtain two embeddings and try to compute similarity measurement. So, and we want to maximize this similarity metric, and once we compute the similarity metric, we will give feedback to the generator how close we are to the textual description, or how far we are away. In this way, we try to optimize the output of this image. So, yeah, based on this approach, like Ryan, the person like called Ryan Murdoch came up with an idea to combine CLIP model and Siren as a generative model. So, and he called his idea Deep Days, which is like a cool name. So here two generations of this method, Deep Days, a time traveler in the crowd and mist over green hills. So why he called this method like as a Deep Days? Because the images have a fever dream or like a hazy quality, as you can see here. And then the same person came up with another idea. So he proposed a new approach, which is called the Big Sleep. So the idea is similar to the previous approach. It is also uses a CLIP model, but this time instead of Siren model, he uses like a big N, the generator of the big N. So he just replaced the big N like siren model with the big N model. So as you can see, like we have like much more like images of higher quality, and the images here have a strange dreamlike quality. So that's why he called it Big Sleep. And then Catherine Carlson finally she like reveals her attempt to combine V2 GAN and Clip together. And here also you can see really high quality generations from her like a model, her like method. And one interesting aspect of this approach is that it allows specifying an image as an input starting point. And if you take the output of the generator and stretch it very slightly, and then feed it back again into the system, you'll take like slightly closer resembling outputs. And if you save these outputs as a frame, you'll end up with a movie with a zoom in effect. So if you jump like to our provided Google Colabs notebooks, you can play around with the text to image generation. And first one is the attention gap model. So we provide pre-trained models already. So just you need to execute cells step by step, consequently. And I already executed them. And if you provide here captions, you can obtain the generation from the attention gap. So here, the example is the man's face looks sad. So the output it is like again like some creepy person, I would say. Yes. And another example, the mountain looks beautiful. So the generator tries to generate some mountain, and which like corresponds to this caption. And then at this point, you may, for example, restart your runtime, because you may run out of the RAM. So if you click restart runtime, and then click again, install Deep Days package, which was provided by Phil Wang. And here it is more interactive. You can place your text description and specify number of layers, and also specify the resolution of the output of the generator. And you can like get like generations, so after some iterations. And the same goes to Big Sleep. So Big Sleep is also provided by this famous like a Phil Wang, who's contributed to this repository. And here is the same text description, but this time like the image quality is much more higher because it uses more advanced generator. So thank you very much. And now I will hand over presentation to Divyansh again, and he will explain about image animation. Thank you very much.
Thank you. Can you hear me?
Yes, we can.
Yes.
Oh, thank you. I will not bore you guys with my introduction again. I will quickly jump to the fun part. Now we will talk about image animation. Image animation, like, I'm sorry, is a very common term. It can be of several types and can be done using, there are several types of software, but I mean, we are talking about creative AI. So the type of image animation we are talking about will be done using an AI, where there is a static image, which we also call the source image. We will make a video using that static image using a driving video. So there is a driving video, and that driving video will generate, use the source image to generate the final video. What I mean is that these are all the source images. So these are all static images, and this is our driving video of a famous person. And these are source images of a famous TV show. As you can see, this driving video is able to drive all of these source images into these image animations. As you can see, they are also able to mimic the little eye blink that we see. So I find these models pretty fascinating. Again, this example is taken from this place by Alexander SAAI, and we will talk about their approach later on. This type of image animation can also be applied to human poses. So this is the driving video here, and these are all the source images. These source images are being like driven by this video, and they're all like able to like imitate the source, I mean the driving video very well. Not only to like faces or poses, it can be applied to any class of object, in this case stickers. So this driving video is animating all of these source images. As you can see there, if you look closely, you may find discrepancies a bit, but overall it's doing quite a good job. So we do all of this by using something called a first order motion. It is again the model proposed by Alexander SAAI, and we will look how they do it. First of all, the key features of this model. First is that it is completely unsupervised. So it does not require any label. So if it were a supervised problem, we would require a driving video frame, then a frame of same pose of this person, and then we would be able to do it. But no, in this case, if we want to train, let's say for faces, we will just require a bunch of face videos. Let's say if we want to train on human poses, we will just require a bunch of human videos. Stickers, then sticker videos. So this is completely unsupervised and does not require any label. So the previous work prior to this work, the first order motion model work, required like the landmarks of like places. So if it were animating like faces, it required landmark of like eyes or let's say mouth, nose, to train it for the training step. But this model even does not require that. So how does it do it? So there are two parts of this model. First is motion extraction and another is generation. So as you can, like, you must be understanding that this motion extraction is responsible for extracting the motion from this driving video. Actually, it's not a video at this point of time. It's actually a frame. So it extracts the motion of this frame. It compares the motion with the actual source image, and it gives us a dense motion map. You may see that there it also extracts key points in between. So it learns the key points of all several type of class of objects on its own in an unsupervised way. We get a dense motion map and an occlusion map. Occlusion map is required, for example, if there's occlusion of the object in the driving video, this occlusion map takes care of that, so that the source image is generated using the context of the source image, not the driving video. So this generation model contains an encoder. After the image is encoded, it is warped using this motion map. And if there are any occlusions, it is multiplied with this warped image. And then finally it is decoded. As you can see, this source image has been successfully converted into a similar pose as the driving frame. If you want to look how it will look over a certain number of iterations, let's look over it. So this is a little animation that I created, and this is how it works. So pretty neat and pretty pretty nice model. I really liked it. I've taken this slide from the YouTube video that the author uses to explain. Again, Alexander SAAI. I'm sorry if I'm pronouncing it incorrectly. So now we also have a demo for this on Collab. Thanks to the authors who have prepared this wonderful interactive notebook, which we can, oh, oops, I stopped sharing my screen. Let me share again. So thanks to the author of this model who prepared this wonderful notebook, and let's reconnect our runtime. Okay, I'll close the notebook and this. So if you run this, first again, it will install some libraries. And if you run this cell, it will create a web interface right here in the notebook for you. So the web interface looks something like this. So you can select people's, cartoons, dolls. You can animate Annabelle as well, by the way, or maybe the It Monster, Game of Thrones characters, statues. So there are all sort of options available. You can upload a custom image as well, and there are some driving videos. Actually, I will stop sharing again. I will share so that I optimize for video clip. Yeah. So once this is done, I will select Mona Lisa and I will select this person's video. And once you run this cell, you will also get this interface, and you can select people and just click on generate. And it takes around 3 to 4 minutes to generate. So in the interest of time, I've already generated and put it here. So let's look at how the generations look like. Pretty neat, isn't it? I find it really amusing and really funny. Seeing Mona Lisa sing. Leonardo da Vinci would be proud of her. So let's present again. So we tried it on Google Colab. I highly encourage you to do that yourselves, and feel free to play with the notebook and extract out the key parts. So now we will look at the example where this is, I think, a speech of Leonardo DiCaprio from Oscars, and we just use Mr. Bean to imitate him. So let's see how it looks like. Quite cool, right? So this is how we can use any source image and animate it using any video, but make sure they are of the same class. If you are using a face model, this should be of the face class, and if you're using a pose model, it should be the pose class. All the options are in the notebook. Finally, I will now introduce our final speaker. I think the most important one for you to conclude all of these demos and presentations.
This example now concludes our presentation. All the best for the SAAI Factory Hackathon. It is now time for question and answer.
Thank you, Mona Lisa, for concluding. So if there are any questions, we will be happy to answer. Please, moderators, please speak out the questions if there are any in the chat.
As of right now, there are no questions, but please, if you do have any, you're encouraged to write them in the chat.
All right.
Maybe feel free, guys, to raise your hands if you have any questions, and please feel encouraged to do so. That's why we are here.
Is moderators, I cannot see the screen. Maybe you can tell me if there are no questions, I can move ahead.
Yep, there are no questions at the moment.
There are no
DJ.
questions.
Yes. Okay. DJ, can you go to the screen that has the roadmap so that all the stops are clear?
Yes, we will go to the summing up screen very soon. Is that all right?
Yeah.
Okay, if we want to see the roadmap again, we can see it here. That's not a problem. So these are all the steps that we went through. First, we looked at style transfer, then style can, music can, emotions style can, text to art, and finally our wonderful Mona Lisa. If there are any questions, please let me know, and we are happy to answer any questions that you may have. Rather, we encourage you to use these examples, use these demos in your projects, and all the very, very best for your hackathon. So again, summing up, these are all the things that we went through. So for all the resources, you can maybe copy this link, and this link should be in the chat as well, and also on the SAAI Factory DevPost website. Please, I would highly encourage you to look at these tutorials and just mess with it and have fun.
At the end, we would like to acknowledge Professor Mohammed Al-Husseini. Thank you for all the time and the meetings and the mentoring you've given us. Thank you for always being supportive.
Thank you. That was a surprise.
Thank you, Professor.
All right. All right. Thanks so much for all your hard work to make this possible. And I want to share with the audience that if you have any questions, you feel free to play with this on GitHub. We can easily go on a Google Colab and just run the cells themselves and play with different options. And I hope that you enjoy the rest of the hackathon. We have yet to come a lot of exciting talks and exciting programs for the rest of the day and for tomorrow as well. And I would like also to remind everyone that at the end of every day, we will have a social gathering, and this is a room for us to talk to more and interact more with each other. So if you may have more questions, you might also ask it later, and also may get together and form teams and discuss with others later today after the right after the symposium ends. The symposium day, we'll have 2 hours of social hours. Thanks everyone, and I think maybe we can. I think the next talk will start in about 11 minutes. Maybe it's time to take some small break, and then come back, or you want to start right away? What do you think, Christoph?
No, I think taking a break for 12 minutes is very, very good idea. But I really want to stress on what you said, Mohammed. It is very easy to get into a conversation on everything that is going on in our and in your minds, all participants that have questions on projects and where and how and so on. It's a very easy way to socially engage at the concluding meeting on Gather Town. So I would recommend, if you have any issues like that. So yesterday we had a talk where we thought, well, that really makes sense. It's much more easier than in this big group. And so you're welcome to join us there. So, and I invite everybody. So that's it. And then we make a break. Yes. Thank you all. Thank you very much.
Thanks, Christoph. Just for a reminder, today it will be from 8 a.m. to 10 p.m. UTC, the social hours, and I just posted the link for on Gather Town. All right. So let's take 10 minutes and come back at wait. All right, let's come back exactly in 10 minutes. That will be 5:30, 5:30 UTC, with an exciting talk about projects by Perry Rees. Right. See you soon.
Okay, hello everyone. Once again, for those of you who are just joining, I'd like to welcome you all to the SAAI Symposium. I'm Isha. I will be moderating along with Arnab, and I'd just like to introduce Professor Mohammed Al-Husseini, who will in turn introduce our speaker, Barry Reese.
All right, thanks, Isha. Thanks everyone for joining. And with utmost pleasure, I'd like to introduce Perry Rees. He's a musician and data analyst at Capgemini. Excuse me if I'm not pronouncing it correctly. In Germany, he's a lead scientist for more than 10 years of experience in state-of-the-art predictive analytics management, strategy, development, and deployment. Originally, he's from the US. He now works at Capgemini in Munich, where he is a full-stack Python developer and a lead scientist. And today he's going to lead a discussion about what is a project. And I think a lot of you might have questions about this because most of you are working on a project. So help us give insights about what defines a good project. And with that, I would like you to take the floor, Perry. Thank you for your contribution and for joining us today.
He should be joining us shortly. If Arnab could put his slides up, that would be great.
Perry, is he?
Yes, he joined the call, but he just suddenly left, so I'm sure he'll be joining soon.
All right. Okay. Caption. All right.
Yes, he's just experiencing some technical difficulties. He's joining very soon.
Okay. Yeah. Oh. All right. Good. Um, Let me. All right.
Okay, so he is still trying, but he can't access this meeting anymore.
Um,
If you'd like, I can proceed with the next speaker as it's a video, and then he can continue to try to log in. And
I think that's a good idea. Maybe in the
yes, no problem. We can go ahead. Arnab, if you can switch over to the video that we are supposed to show for Eike Langberg.
okay. I think we need to introduce him as well.
Yes, I can go ahead and introduce him. So again, thank you everyone for joining, and thank you for your patience. Again, I'm moderating, so if you have any questions, you can direct them to me. And we'll continue to wait for Barry to join. In the meantime, we'll go ahead and show Eike Langberg's pre-recorded video. He is a professor of media informatics at Hamburg University of Applied Sciences. His fields of work include extended reality and games. He studied computer science in Oldenburg and Hamburg and graduated with a PhD thesis on perceptual aspects of virtual reality, locomotion in 2019. In 2020, he co-founded Curvature Games, a Hamburg-based game studio specializing in narrative virtual reality experiences. Since 2012, he has worked in the game industry as a programmer and game designer on titles for different platforms, including web, mobile, and virtual reality. Eike's research is focused on 3D interaction in spatial environments. It is driven by the question of how stories can be told in interactive media. He published in the most competitive conferences of the field, including ACM SIGGRAPH and IEEE Virtual Reality, and is actively involved in the research community. Eike is a member of the IEEE, ACM, and GI. He is on the program committee of the most renowned conferences in the area of virtual reality and augmented reality, and serves as a reviewer for several national and international conferences and journals. And with that, we'd like to play a pre-recorded video lecture that Professor Langberg has kindly shared with us. So if Arnab, if you could play that, and thank you everyone once again for your patience. There's no audio.
I think you need to share with the audio. I think the share screen, and there is an option to share audio.
At the Hamburg University of Applied Sciences, and I'm really proud to give this talk at the hackathon, because the hackathon is also dedicated to the connection or to the mix between art and AI. And I think that games are one of the most interesting modern forms of art. So I hope this talk will fit pretty well to the interests of the participants of this hackathon. So in this talk, I want to give an introduction to the topic of interactive storytelling, of the way, of the kind of way you can tell interactive or stories in an interactive way in games. And I will also raise the question how we can use AI for creating these stories, or at least for helping in the creation of those stories. This, I won't answer so many questions in this talk, but I will raise a lot of questions. So it's not about, how can, pick this AI algorithm to create a story and then you're done. It's more like, hey, so far we did it this way to create our stories for our games. And this was done by humans. And now the question is, how can we involve an AI into this process? So in the beginning, just a few words about myself. I'm a computer scientist with a focus on human-computer interaction, game development, and virtual and augmented reality systems. I worked a couple of years in the games industries as a programmer and game designer. I also co-founded my own game studio, Curvature Games, where we develop virtual reality games that are also very narrative driven. And since the beginning of this year, I'm a professor at the Hamburg University of Applied Sciences, teaching and researching in the area of these topics, HCI, games, VR. And during the course of my work in the games industry, I worked on a couple of games that were very narrative driven, or where the story was yeah, a centerpiece of the games, like Frozen Factory, or also the Amusement, which are VR games. Especially the Amusement is a narrative-driven game, also so-called walking simulator, where the story is actually the heart of the game. So I'm pretty much familiar with interactive storytelling, at least traditional storytelling, which is done by humans. And now the question is, hey, how can we involve AI into this process of interactive storytelling? But before I talk about games, let's start with some basics of storytelling in general. So yeah, always when you want to tell a story, for example, in a book or in a movie, you usually have kind of story arc, a structure that you use to create your story. This is one of the most classical approaches, the 3-act structure: exposition, climax, resolution, and you have kind of rising action, rising tension during the course of the story, and then falling tension in the end. And you can use this structure to, yeah, to structure your story. So to help with the creation of the story. There are also other structures, or more sophisticated structures, like the hero's journey is also a very popular one that describes the journeys, like the different steps that the hero needs to take during the story. And this can help with the creation of your own story when you know, okay, I need to have these steps inside my story, and then it will build up tension, it will be interesting, and so on. And since these are, yeah, structures, they are also, yeah, learnable by machines. And this is where AI comes in. So at the moment, it's already possible that AI, so machines, can create stories in form of text. Especially the GPT-3 AI from OpenAI is, I think, at the moment the best AI for this. And there are some examples. For example, last year there was an article in The Guardian, which was completely written by GPT-3, and the same AI also is known for writing poetry. This is another example, also generated with the help of GPT-3. Of course, there must be a human who gives some input to this machine, but then the algorithms do the rest and create this. So at the moment, these are only like smaller pieces, smaller articles of poetry, but it is very likely that in the next couple of years, AI will also be capable of writing whole stories, like books or screenplays for movies. I think it's not anymore. Actually, I don't know of any book or movie that was completely written by an AI right now, but I think it's not the question anymore if this is possible, only when, and it will be in a couple of years that we see at least AI supported stories in traditional linear media like books and movies. So, and this is because these machine learning algorithms get a lot of input. They can read books, they can watch movies, and then learn how these stories are structured to create their own stories. One interesting piece of research from the MIT is here. They taught a machine to watch movies and analyze the movies. This is an example from Up, the movie Up, or only the opening sequence of the movie, and their machine, or their algorithm, gave scores to the different moments, to different seconds of this scene. And these are scores between 0 and 1, and you can see like this, the whole scene is 12 or 13 minutes. And you can already see that this is pretty similar to this 3-act structure that I showed in the beginning a couple of slides ago. So the tension or the action is rising until the climax, and then it's falling again. So a machine can already understand where they find this pattern, can already find this pattern in any movie or book. So, and this is the first step to be able to create a story on its own. When I say like an AI can create a story, maybe I also don't mean that it does this alone, but it still needs input from, like, a human needs to ask it questions, and then the AI can answer with a text or a story. And often, even if this is not perfect from the beginning, this then again can be used by a human to to tune and to polish the story. So, but how about games? In linear media, books or movies or news articles or so, we only have the story. Like, it's only some text that needs to be generated. Yeah, of course, and the text needs to be written in an interesting way that builds up tension and so on, but we only have the story. In games, we do not only have the story. The experience of the game is made up by two pieces, basically, the story and the gameplay. And most often the gameplay is even more important for the experience of the game. So let's look into gameplay first. Like, AI was used in games since years, but it had a little bit of different meaning in game development so far. So when we look for AI in games, most often we find just simple decision trees or pathfinding algorithms for computer controlled characters in the game. So an enemy in the game needs to know when he should hide, or when he should seek the player, when he should shoot. So this is made of by decision trees. Or enemies or in general computer controlled characters in a game need to find the correct way from one point to another. For example, A star algorithm is used very often here. But this is not what we mean by modern AI, which is based on machine learning. This is pretty unfamiliar for use in game development. But I don't want to put too much emphasis on that. This is not the topic of the talk. Just wanted to show, okay, AI was used in gameplay, okay, but it's not the AI that we're talking about right now. Let's go on. So we have gameplay, we have story. How do we connect these two things? There are several possibilities. One is to do it like this: have one piece of gameplay, and then we have one piece of story, and then we have one piece of gameplay and then story, and so on. This means, like, you play a little bit, like, I don't know, you fight against an enemy, and then there's a stop, and you, I don't know, have a dialogue with a character, or you watch a cutscene, which is basically a movie, but you don't have any interactions during the story parts. We can also watch an example for this.
Crap. This is really not good. Hold on! Nathan! They're gaining us! I know! Well, crank it! I'm going as fast as I can!
Okay, the first part was a cutscene like the movie, and now it's switched to gameplay, and they can actually control the character and shoot enemies here with and so on.
Got it!
What I wanted to show is just, it's pretty separated. First the story, then the gameplay. And it's a pretty linear also, you don't have much choice. Another possibility that is also found very often in games today is the branching approach. So at certain point in the game, the player can choose which way he wants to go, like in which direction should the story go. There are some decisions, and depending on the decisions of the player, the story continues. Yeah, also an example of this.
Listen, I know it's not your fault. These emotions you're feeling are just errors in your software. No, it's not my fault. I never wanted this. I love them, you know? But I was nothing to them. Just a slave to be ordered around. I can't stand that noise anymore. Tell that helicopter to get out of here.
The situation is under control.
There. I did what you wanted. You have to trust me, Daniel. Let the hostage go and I promise you, everything will be fine. I want everyone to leave. And I want a car. When I'm outside the city, I'll let her go. That's impossible, Daniel. Let the girl go, and I promise you won't be hurt. I don't want to die. You're not going to die. We're just going to talk. Nothing will happen to you. You have my word. Okay. I trust you.
Okay, this was from Detroit Become Human, and as you could see, at certain points, the player could decide what to answer, and depending on the answers, the story took a different direction. And here you can see the scene in as a whole with the different branches and the different possible endings for the scene. The one we just saw there, the guy was killed in the end, but there are some other possible endings. So for these kind of games, like where we have story and gameplay pretty separated from each other, there exist a lot of tools that you can use to create these kind of stories, like RTC Draft, Arcweave, or Charisma. It's just like graphical tools where you can put in your story and connect the different pieces and even put in triggers when they should start or when they should be played. And basically the story parts are always just like more or less like movies. And if they're like movies, we could just have an AI write the screenplay for this movie or this cutscene. And in between we have gameplay, but the story or the gameplay, but no, other way around. The story is not affected by the gameplay, really. So it's not such a huge difference to a movie. So we could just use an AI to write the texts or the screenplay for this, and then use this as input for such tools that you can see here. And then we would have also an AI written story in a game. So at least when it's also possible that an AI writes a book or a screenplay for a movie. But in games we have some more problems. So especially the connection between story and gameplay is important. So a game is interactive, and the player can do things in a game that are not possible in a pretty linear media like a movie, and this can cause problems. This can also cause story problems. So one pretty prominent problem is called the ludonarrative dissonance, because there's a gap between the narrative that is told through the story and the narrative that is told through the gameplay. Like I brought short examples to understand this better. So this is from Tomb Raider, and pretty early in the game, Lara Croft needs to shoot a deer because she's hungry and she needs something to eat. And in a cutscene, she goes to the deer that she just killed, and she's pretty sad and cries and is very emotional about this, and she's very sorry that she had to kill this animal. And this does not really fit to the gameplay of the game, which looks like this.
Up there! She's on the second floor!
So, as you can see in the gameplay, Lara has to shoot a lot of enemies, human enemies even, and she does not cry or is emotional about this. So here the narrative told through the gameplay and the narrative told through the cutscene do not match. There's a huge gap between them, and this can cause this little narrative dissonance. And this is something that would also occur when the story bits are just written by an AI and the gameplay is completely separated from this. So we need some kind of connection between this two to really interweave gameplay and story with each other to be able to tell a good interactive story. And I really like this quote from Bob Bates, who's veteran game designer. He said, story and gameplay are like oil and vinegar. Theoretically, they don't mix, but if you put them in a bottle and shake them up really good, they're pretty good on a salad. And this describes it really good. So I collected some methods that make us able to do this, like to bring together gameplay and story, at least in a traditional way, like created by humans, not by AI. And we will look later if this could also be done by an AI. So the first one is emergent storytelling. Emergent storytelling means we do not really have a story that is written by an author that is predetermined, but the story just emerges from the gameplay. So from the interactions with the different systems of the game, or just by random events. And one pretty good example is this one.
Got a little soul, the world is go place to be.
Welcome to a world full of exceptional Sims. Smarter, with big personalities, who every day collide and connect. They are yours to create and control. Their stories are yours to tell. There's the story of Ollie Perdue, a starving artist without his muse. Depressed, Ollie spent his days alone, and his nights seeking inspiration. He didn't laugh, and he didn't dance. Babs Lamore, a bartender, had dreams of her own. A romantic, she was forever on a quest for true love. Until she met the one. Ollie fell for her way with words, and his technique left Babs inspired. The budding novelist began writing her own story. The story of Babs Lamore and Ollie Perdue.
Okay, and so this is examples from The Sims, and The Sims is just a simulation. You don't have any story in the game, but you can do whatever you want with your player. You can act with the systems of the game, you can interact with other characters in the game, and from this you can write your own story. So the player has full control over the story that he or she wants to write during the time he plays the game. And this is called emergent storytelling. Another method is environmental storytelling. So environmental storytelling means the story is not told by dialogues or cutscenes, movies, but just the environment around you that you're exploring tells the story. So you could find interactive things in the environment, like documents, messages, audio logs, books that you can look at, or even the whole setting, the furniture around you. If you enter a room and it is messed up or it is cleaned up, tells you something about the person that is living in this room. And this is called environmental storytelling. And I have an example from a game that only uses environmental storytelling. So this
Katie, I'm so sorry.
This is from Gone Home, and you don't have any dialogues or cutscenes in this game. You're just exploring an empty house. Just by exploring this empty house, you understand what happened there. Like only by this, the story is told.
We moved into this house.
Good. And the last one, last method that I have is like tell a story through interactions. This means this one is predetermined. It has an author that wants to tell something, but we don't use cutscenes or like really linear movies, but the player has a control over the gameplay all the time, and the story is really told in an interactive way, just through the interactions you do as a player. I also have an example for this. This is from What Remains of Edith Finch, where the player plays
Dear Mrs. Finch,
a guy that has
as
a really
Lewis's psychiatrist,
boring,
I can understand your desire for an
boring and
explanation.
repetitive job
As I see it, the
in a
trouble
fish
began in
factory.
January, shortly after we convinced your son to seek treatment for substance abuse. Newly
And
sober,
because it's
I
so
believe Lewis
boring and
first noticed
repetitive,
the monotony
he
of his daily
escapes into a fantasy world. So the player
He kept working at the
needs to
camera,
do this boring repetitive task on the one hand,
but he withdrew
and
part of himself.
it's really always the same, but at the same
In our
time,
sessions, I
you
saw
see
the
this in a
same
moment,
behavior.
he needs to control the imaginative
His
character
mind
in this
began
fantasy
to
world.
wander.
The guy that you play is
I asked him to describe it.
it's imaginative world. You see this
He
now
said
here,
he
it's
started
overlaid
small.
on the other screen. And this
Imagining a
transport, this
labyrinth.
feeling, like the story should, or the
He'd feel his way about.
interactions really transport the feeling of being in one place, but also being
Then
at another
something moved.
place, in this
Bats.
fantasy world, just in your mind. And you control both at the same time, which is a little bit difficult and challenging.
And things that have not names.
This is actually a pretty good way to tell
He knew it
this in an interactive way. Okay, so I gave you 3 methods how you can like try to connect gameplay and story: emergent storytelling, environmental storytelling, or storytelling through interactions. And now the question is like, could this also be done by an AI, or do you need a human to do this? I said like in the beginning, yeah, it's pretty, pretty likely that we will have books or screenplays for movies that will be written by machines in the near future, and also for this pretty linear stories in games, or so pretty separated, where the games where the story and gameplay are pretty separated. This might also work when it works for movies, but for these more interactive techniques, emergent, environmental, or interactions, is it also possible to use an AI to write these stories? And I don't have an answer to this, but this is a really interesting research question. And maybe this is also something that could give you ideas for your projects during the hackathon. I have one last example, a little glimpse into the future of what might be possible with AI in games. This example is in Modbox, which is a kind of game creation sandbox. So you can create a lot of things in this, and it's possible to visit then your creation in virtual reality. And someone connected this, or like the makers of this connected this to the Windows speech recognition, so the player can actually say something which is recognized. And then they connected it to OpenAI's GPT-3. So they would, they use the recognized voice as an input for the GPT-3 algorithm, which creates an answer, and then this answer is made to sound by Replica's natural speech synthesis, and this looks like this.
Hello, Bobby.
What do you want?
Where are you going?
I have to go to work. I'm already late and my boss will punish me if I show up even later. Please leave. I can't help you right now.
Where do you work?
I work at City Hall. It's a government building in the center of town. It's a huge and beautiful building. You can't miss it.
What street is it on?
You're smart. I like that about you. City Hall is located on City Hall Street location.
Alright, goodbye.
Goodbye!
Okay, we'll talk to this hot dog man. Hey, hot dog man.
What can I get you?
What kind of hot dogs do you have?
We have 3 kinds of hot dogs. The normal hot dog, the sweet hot dog, and the very spicy hot dog.
Can I get a deal? 3 for 1 hot dog?
Sorry, we can't do that. The customers would not like it.
Well, how much is a hot dog?
One normal hot dog is 6 coins, one sweet hot dog is 10 coins, and a very spicy hot dog is 9 coins.
What makes it so spicy?
It has some Tabasco sauce on it that makes it very hot.
Alright, goodbye.
Goodbye.
Okay. This example still has some flaws. Of course, you need to wait for an answer very long. Sometimes it does not really fit together. And of course, this is not a story yet. It has no story arc, no rising tension or something like this. Is something that you will need to add to this. But I think it gives a very good impression of how you could experience a story or an interactive story in games in the future. And yeah, this concludes my talk. Thank you much for your attention.
All right, thank you for those of you who stayed with us. We are going to go ahead and start with our next speaker, who is Barry Reese. He is a lead data scientist with more than 10 years of experience in state-of-the-art predictive and analytics management, strategy, development, and deployment. Originally from the US, he now works at Capgemini, I'm sorry if I pronounced that incorrectly, in Munich, where he is a full-stack Python developer and lead data scientist. All right, thank you, and it's over to you, Barry.
Hello, can you hear me?
Yes, we can.
Okay, great. I was muted and yeah, thanks for the introduction. Very, very interesting presentations today. I love the content. That last one was very interesting about the game design. As Isha mentioned, I'm Barry Reese. Can you go to the next slide, please? Okay. Yeah, I'm Barry Reese. I'm a lead data scientist. I mostly work on commercial applications and AI. Most recently, I'm working on quantum neural networks, which is a use case where you're trying to. It's a convolutional a neural network, but we're trying to get the benefits of quantum computing and quantum sensors. Interesting stuff. I live in Munich, as Isha said, and today what I'm going to talk about is how to structure a project. I've gotten a lot of questions in this hackathon about people that they don't know how to build a project or how to start one, or ideas for a project. And my audience today are people who have maybe never done a hackathon before, or if you have done a hackathon, maybe you weren't in charge of setting up a project. So these are people that are new to hackathons and never done it before, and maybe don't have a lot of development experience. And I'm going to try and stay at a high level and just go through some basic stuff. Can you go through the next slide? Thank you. So yeah, at a high level in a hackathon, your project, it's gonna have three main phases. Your design, build, and present. And so at the beginning, when you design a project, you are looking for a challenge you want to tackle. So for example, a challenge you want to tackle would be, let's say it could be something new technology for something of your interest. It could also be something like improving something that already exists. What is a hackathon not? It is a demonstration of how to use somebody else's software. That's a big one that some people ask, can we demonstrate some feature? No, it's in this hackathon, it's not really a focus here. It's generally building something new, taking a use case in art and doing something with it, or improving an existing technology. And once you've decided upon that design, you're gonna go through this build phase. And so in this phase every team is going to be different, but in the build phase, you want to structure your team. You want to resource the members of your team and try to put them on tasks they're going to be successful at, or what they'll find interesting. Sometimes in a hackathon, you'll have a complete team at the beginning. You'll know who you're going to work with, and it's clear. Other times there's a lot of individual participants that we have or could be out there, and you might want to coordinate with people who are individuals, maybe not on a team, and go to them with your ideas and ask them, based upon a skill they might have or an interest, whether they want to join your team. And that's what we call building a team around an idea. But in any case, in this build phase, the hackathon it's really all about team spirit. And you want to work as a team and surround yourself with people with the skills to make your dream a reality. But what is very important in a hackathon, particularly in this one, is this presentation. And what a lot of people that really have never done, and actually I've been on a team where we almost got caught with this, where we didn't give ourselves enough time to make a presentation, because it's important that you communicate your ideas, your solution, you communicate that to the judges. It's important. And if you've never given one of these before, it's fine. A lot of people haven't, but in general, at a high level, those presentations are going to have three main parts. First you're going to talk about your idea. You're going to give a problem statement, challenges and how you overcame them, and then your solution. And that's how the presentation normally goes. If you have any more detailed questions about what to do for your presentation, we're happy to answer those. I'm not going to go into a lot of detail about right now about specifically how to structure your presentation, but the key thing that you want to take away from this is give yourself adequate time to make a presentation and to present your ideas. Anybody, is everybody following me so far? Does anybody have any questions?
If anybody have questions, you can just write them in the chat.
Sure. Yeah. Okay, so let's go to the next slide. And I'm going to go through right now for people, in my opinion, you can, as long as other people are okay, this isn't something I thought of. It's a simple idea. And I'm going to go through this and just talk about this idea and questions that people normally might have and how I would go about answering them. And this is just it's a project example idea. A lot of people think it's cool to have an avatar of themselves in 1980s graphics. So you take an app where you could upload one of your own photos, pixelate it with some cool, 80s graphics, and then download an image that you can use. Would be a pretty simple use case. And then you build the app, you've got an image, you upload it, you pixelate it, you download it, and then you serve it out there for people to use. And like the biggest question that people, when they think of a cool idea, they want to put their idea together. And that's what this first, so the question is, how do we develop this? And then I'm saying the answer, just start with, when you say, how do you develop this? Like, just structure your idea in a clear way, and be able to explain it. That's the first thing. And then once you've decided how you can develop it, what your idea is, then what you would do after you decide what your idea is you have to decide on what your MVP is. And MVP means minimum viable product. And there's another slide after this one about the MVP that I'm going to talk a lot about. But that's generally when how do you develop it, your story, your vision, you decide on this MVP. And then from there you go, okay, well, what skills do we need? And so for this app, given our use case, given what we're going to talk about what our MVP is, we know what skills we need. We know that we need somebody that can build requirements and then review those for the UI. UI means user interface for the app. This person should have an idea of what's possible in Python Dash, because as I'm going to talk about in the next slide, Python Dash is how we're going to serve this up. This person would be responsible for architecture deployment. And we need a couple of Python developers because this is going to go on in Python. And let's suppose that our team is new. We don't have a lot of experience, and we may need to look at a couple of courses on Udemy or some other course to get up to speed in Python. And then, so I'm saying, how do we present it? Once we get through, when we present our MVP to the judges, we'll present our app in Python Dash. We'll go through the what I talked about on the other slide, the problem, the how we solved it, and the solution. And then it's always a good idea, if you're presenting an app live to judges, it is always a good idea to have some backup slides in case there's an issue with a live demo, because I had problems in this talk tonight and didn't have a backup plan. So learn from me that, these technical problems always can always happen. So when you just have a backup plan for whatever technical difficulties you might have. And then so the other one is, what if I don't know the code off the top of our head? Like if you have a coding challenge, you're building your app, you don't know a piece of code. If you've never, written a lot of code before, it's gonna be very daunting. It's normal. It's completely normal. Don't get frustrated. But what I'll do it, a lot of responsible or experienced developers will do, if they don't know how to write a line of code, they'll use Google, Stack Overflow, take some Udemy courses. And if you can't find anything out there, just, call one of the mentors. We're happy to help. I like to actually look at and learn from participants and people that have questions. Like I actually really learn myself from answering your questions, because it gives me a glimpse into how other people think and what other people are understanding. And, the mentors we're always here to help you solve, challenges you might have and make you successful. And like, as I said, in hard coding cases, I use these online resources all the time. Sometimes, in some cases more than others, but this is normal. If you don't know code, just don't get frustrated. That's the big thing. And don't be afraid to ask. Don't be afraid to use Google. That's the point. And then let's go to the next slide, please. So as I said before, the minimum viable product, MVP. This MVP is something we talk about this in industrial applications all the time. It's something on nearly anytime we're developing a new solution. This is you'll hear this a lot. I mean, you won't always hear it called an MVP, but it's the same thing. It's the crux of your problem. It's what you want to make. You'll make this decision early in the project, and the MVP is what you want to get to. It's where you want to get at the end in order to prove your concept. So, for example, in our case, our MVP is an app in Python Dash where we can demonstrate that a user can navigate to the browser, upload an image, pixel it, and download the image. We will present ideas of how we think our app can be deployed. And notice that my MVP is not a deployed app, right? My MVP is only to demonstrate. I mean, what I mean by not a deployed app, what I mean by that is it's not live so that users can actually use it. It means that I can have a build time, I can get to it in a browser, and I can provide a demonstration of the app, for example. But if you would like to talk about the next stages in live deployment, you can definitely do that. And if you want to, you can test a couple deployment strategies. So that's what our MVP is. And I think I said it, but I want to make it clear that the MVP is where you want to get to. It is your goal. And it's, you'll hear in practical applications, you'll hear about this and you'll talk about it all the time. So when you're doing a hackathon, this is a good way, if you plan on being a developer, it's a good habit to get into, to start thinking towards where you want to end up. And the last thing that I want to talk about here is what happens if you don't get to your MVP, right? What happens if we have constraints or difficulties? You don't have to finish it. I mean, you should try, but just let's face it, like, projects are not always successful in AI. They're not. But it doesn't mean that we can't present what we did accomplish, what we learned, and what we think we can do next, because sometimes some of the best successes actually come out of failures. You'll see it a lot in industry. And so just, talk about what you learn and what you think you might do next and how you think this might benefit the industry. And the most important thing to remember is that a hackathon is mostly about team spirit, and it's about growth. And, just remember that. And let's go to the next one. Slide, please. And yeah, that's it. I really just want to thank you for your time. I hope I've shed some light on some of the questions that we've had. I hope I've explained what a project is, how to structure one, and how to go about doing one. If you have any questions or if I missed something that you want to know, please, reach out to me, and I'll just open it up real quick for the last couple of minutes. Does anybody have any questions?
Please feel free to ask the questions on the chat and I can relay them to Barry.
Yeah, sure.
I got one behind the slideshow. How would Python dash be used as an alternative way of how would I say this? When we're doing with like a full stack and we're working with all the processes, how would Python dash, instead of doing all the processes of the full stack, why should we use Python dash unless it's for something like an agile methodology?
So don't confuse your technology stack with your project management methodology. They're separate issues, but the reason why I've suggested Python dash in my use case is because in the Python dash framework it's a coupled stack. You know what I mean by a coupled stack? Coupled versus decoupled stack?
Yes.
Okay. So yeah. So when you can write your front end and your back end and dash and structure those through callbacks, and the dash app will it'll write your HTML and Jinja for you, all in the same in the stack. So yeah, I mean, I use it. I like it a lot. There's a lot of things I don't like about it, but honestly, for if you're a Python developer and you're just getting into app development and you're just trying to learn the stack, I recommend going with to start out with a fully coupled stack, and the dash is a great way to do that.
Okay, thank you.
Because yeah, you don't have to write any HTML. You don't have to use Jinja. There's a little bit of ramp up with how the callbacks work in there, but it's not extremely steep. I wouldn't say it's as steep as trying to learn Python and Java and
everything at the same time. Yeah.
Exactly. Was that a good answer to your question?
Yes, it was. Yeah.
Okay.
Thank you so much.
Okay. Yeah, you're welcome. Anything else?
There aren't any questions on the chat, but please, we encourage you to ask any questions. All right, I think that's okay. Thank you so much, Barry, for your time. I enjoyed your presentation thoroughly.
Thank you.
And yeah, we can go ahead and get started with the next speaker. Again, thank you so much.
Okay. All right, everyone. We'll enjoy the next speakers, and thanks for having me today. Bye.
Thanks for joining.
Thanks, Barry.
All right.
Barry.
All right, everyone. For those of you who are new, again, hello. My name is Isha, and I'll be moderating the last workshop of today's session. And it is my pleasure to introduce Arij El-Wabil, who is an associate professor at the College of Engineering at Al Faisal University and the director of Al Faisal's AI Research Center and the Human Computer Interaction, HCI, Design Lab, which is a multidisciplinary research and development center specializing in emerging technologies. Her human-centered approach to developing emerging AI technologies focus on improving everyday workflows and quality of life by augmenting human abilities. From brain sensing to eye tracking and mixed reality, the AI Center's award-winning technologies are changing the way people with disabilities work, live, and learn. Through such experience, she has developed a deep knowledge of trends in emerging technologies, innovation ecosystems, medtech, intellectual property, or IP, creation, and intellectual property commercialization. Towards that end, Dr. Arij served in the role of Executive Director of Intellectual Property Enablement at the Saudi Arabian Authority for Intellectual Property in 2019 and led the team which spearheaded Saudi Arabia's network for WIPO's Technology and Innovation Support Centers across universities and industry in the kingdom. Prior to that, she completed her postdoc training at MIT's Ideation Lab in the School of Engineering as an Ibn Khaldun Fellow and was an honorary fellow at the University of Kent School of Engineering and Design. Before we get started, I would like to request those of you who may want to ask Professor Al-Wabil any questions, as I'm sure you will, to please save them until the last 15 minutes of her workshop, as she has dedicated this specific time for a question and answer session. She will also be going through several activities throughout her interactive workshop that will allow you to actively engage through the chat function on Zoom, so I encourage you to participate. And with that being said, thank you so much, Professor Al-Wabil, for joining us, and the stage is yours.
All right. Well, thank you very much, Isha, and welcome everyone. I'm very excited to share this workshop with all participants, and it has been a vibrant day, a wonderful program of speakers, and I do hope that this workshop also complements the diverse topics that were covered in today's program and in yesterday's presentations and lectures. Now, this is a hands-on workshop, so there will be some activities, as Isha mentioned, and I'll be switching between the slides and some resources that we'll explore together. What I do promise is that it's not heavy on coding, so we won't be doing any development. However, we will be introducing you to some of the platforms. Now, before we start, I just want to make sure, because I have multiple screens open, a visual check with Isha. So is the screen maximized on the title page?
Yes, it is.
Okay, very good. All right, everyone. So the workshop's scope, the topic is reality engines, and we're looking at virtual reality, augmented reality, and mixed reality. And what I will be starting with is a general overview of the scope of work in the digital realm with a little bit of history in looking at how technologies and tools evolved in the past 4 or 5 decades. So the applied context will be art. So many of the examples that we'll be sharing will be in the context of creative works and artistic expression. And we'll look at how these technologies have been designed for all senses, the visual, the auditory, and the tactile. So there's a lot of interesting and fascinating work in these domains, and we'll touch on the input and the output and the processing that goes on in such systems. So the digitization that we're all experiencing has transformed our societies, but what we are sensing in this phase of technology development is that the realm in which we live is unrecognizable when we compare it to a few decades ago, in that the interactions are different. The insights that we can gain from people interacting with medium is at a level that has not been feasible given the technologies a few years back. So the potential for technology to enhance the user experience in physical and digital worlds has enabled the participants in this domain to propose different ways of interacting, and this is what we will explore together. Now, the technology advances, the two advances that were key to the development in this field are mainly wireless connections. Once technology became untethered, it became more viable for interactive environments or immersive environments to be available to users in their homes, in their schools, and other public spaces. Another advance is the computational power, the processing power of the visual realm or the auditory data sets that are, or streams, data streams that are required to create the illusion of being immersed in virtual environments have advanced where it can be packed within headsets, whether it's tethered or untethered. So these two advances have led to a proliferation in the solutions or the creative works that we are seeing in these domains. Now, the scope of the workshop mainly is to focus on reality engines, and that is to introduce some of the tools that could be considered for artistic expression, which is aligned with the scope of the SAAI hackathon or the SAAI factory that we're all engaged in. So we will be looking at two of the leading reality engines, Unreal and Unity, and then we'll look at the OpenXR platform and how those tools can be considered, or the platforms can be embedded in the systems that you might be creating. Sorry, I don't see the screen changing. So let me make sure that the screen that is visible here on Zoom, yes, this was the workshop scope that I was describing. And at the moment we are looking at the topics. So the learning objectives, basically, or the topics that we're covering here is the different types of extended reality. So we'll look at the physical virtual continuum from augmented reality all the way to extended reality. And we look at the terminology just to make sure we're on the same page when we refer to these technologies. And then we'll zoom into the reality engines. We'll take a look at the learning resources and the tools, and we'll also have a reflection point in the workshop in which we look at the pros and cons of each platform. If you are undecided and not sure which one is right for you, we will discuss that a midpoint throughout this workshop, and then we'll look at the OpenXR platform. We'll close with a few use cases, perhaps to spark interest or inspire you if you haven't consider the virtual realm as a medium for artistic expression or for engaging with your audience, so that you can understand how these technologies have been applied by others in the 4 areas or domains that we have in SAAI. And these are motion movement, images, pictures, text, language, audio, and sound. All right, so let me make sure the flow of the slides here. Okay, so we'll start with a bit of history. Let me switch here the video so that we can focus on the visuals. The history of art and technology have always been intertwined, and what we have seen is that the tools evolve. However, the artistic expression.
Doctor, the voice is a little bit has a little bit of a noise background. I'm not sure if there's something you can check on your end.
The audio. Let me check. Okay, so I will be pausing for a moment. Sorry, everyone. Excuse us. All right, so Dr. Muhammad, we switched microphones. So is this any better for the audio? And I can speak also louder.
Much better. Yes.
Yes, much
Oh,
better.
Good, excellent. Okay,
Thank you so much.
I'm glad that was resolved, and thank you for the heads up.
Sure.
All right, so we were looking at the history of art and technology and how the tools have evolved over time. And with the new tools being introduced, artists usually embrace the tools and explore different mediums and different ways of showcasing their work for audiences. The transition that we're seeing with extended reality is that the roles have changed, and that audiences are embraced to walk into the artwork or explore it in a different way. So the tools we use for creative expression have evolved, but also the experiences of the artists and audiences have also changed in the ways that art is being brought into the digital realm. Now, if we roll back in history and look at digital art as a concept, there has been a different definition in what constitutes a digital piece of work. But to make sure that also we are aligned in how we refer to this medium, we wanted to start with some terminology in that if we look at the past few decades, it was basically an expression in the digital medium of creative works. So the artists were using the digital medium or the algorithmic creation to express some form of art, whether it is visual or auditory or even language-based. In some cases, it was transitioning and showcasing the artwork in the digital form. So in the early years, it wasn't just technology as a tool, but it was more of using the digital technology as a medium to create and showcase and engage. But the engagement was limited to the interfaces or the GUIs, the graphical user interfaces that were available at that time, if we look at a decade or more ago. The engagement increased with the availability of more immersive experiences. So if we look at this exhibit, and the audience can also visit the website, we'll share the slide deck that describes the rules, codes, and choreographies in art that looked at it in a span of 50 years. It looked at the effect of digital media, how it has enabled artists to express in a different form or to reach audiences that were otherwise inaccessible. So art became more accessible, but also new forms of art emerged with the medium being accessible and available to artists. So some artists were engaged in the actual coding, whereas others used the tools that interfaced with the back-end coding that is required for such creations. This exhibit drew on the historical connection between the conceptual video and contemporary digital art that was not immediately obvious. There are similar exhibits that also reflected on the intersection between art and technology. Now we're zooming in closer to the relevant topic of assets in extended reality applications, and this takes us to the digital realm of pixel art. Pixel art started with the limitation and constraints that designers and developers had with the machines at that time, the 80s, the 90s, even before the internet, in which the limitation on the computational power and the graphic interfaces limited what could be drawn, what could be rendered on the screen. So you can see here how it evolved over time. And then there was the slow downfall from the 80s and the 90s. It was growing in popularity, and then the downfall of pixel art as more powerful gaming engines evolved, were introduced and emerged. The design transitioned to more to rich visuals. And it has always been a captivating prospect for designers and developers. So it started as a workaround for technical limitations of the machines at that time. It was utilized, refined to the point that it was ubiquitous in the gaming culture in general. Now, the highs and lows that it faced eventually resulted in developers using pixel art in some cases as an artistic choice instead of a shortcut for primitive or limitations in the technologies that they had available. So if we look at now the concept of digital art, not limited to the pixel art, and these are the digital-born art creations that were created, stored, and distributed via digital technologies. This is what we see in our current times. Examples are the Beeple NFT, the art creations that are used or shared as what we call them assets in the digital marketplaces that are linked to the reality engines. And then there are the creations of the digital creations and the scope of work that looks into the preservation of that type of digital form and the distribution, the context of sharing and distributing such artworks. Now, what we are witnessing in recent years is the features are evolving to bring the art closer to the audiences and also engage the audiences with the artwork. So while all these characteristics are not are exclusive to digital art in terms of the interaction design, they are also seen in other art forms such as the performative events or video art. So they're not intrinsic elements of objects such as the static artworks in which the user needs to be present in a space to experience them. So the design of such experiences does require catering to all the senses, the visual, the auditory, and the tactile. So these installations have the option of designing for real-time interaction. It could be interactive, even if it is not synchronized. It could be process-oriented, and in some cases performative, where the users are interacting and influence what is being seen and what is being experienced in such contexts. So if we recap here with the transition that we are highlighting in how design has changed or how the design of such technologies has evolved, we have looked at the expansion in the range of artistic practices. From advancing the concepts originally explored in conceptual art or art in general to generating new realms, these are the virtual worlds or new mediums in which the user can interact, from the visual, auditory, tactile, even olfactory, and the sense of smell in the way users experience digital worlds or virtual worlds. Okay, so now as we move on here, there seems to be lag, but let me make sure we're on the same page. Okay, so the point here is that the traditional notions of artwork, audiences, and the artist have changed, and in designing such experiences, empowers the artist to expand the scope of what could be shared or presented in a different way. Audiences also have the experience to explore what is relevant or to follow their curiosity and understand it from their own perspective if the information is layered or the artwork is layered, and they can explore it in different narratives or in different modes, which the technology actually affords and facilitates. So the artwork itself is transformed. It's usually open structure, and the process of showcasing, capturing it, showcasing it, and making it accessible relies on the flux of information. Now, when we say information, we're referring to the data streams, the visual, the auditory, and even the language or movement, and we'll take a look at that embodied in a few examples that we'll explore together. Now, it's very much similar to performance, and the way a performance is designed to engage with audiences, but in some cases here you could rewind, you can capture and re-explore the medium in different ways, which is often not afforded by the static performance type of context. Okay, so the audience becomes a participant rather than a viewer or an explorer of a collection, in that in some experiences you can allow the users to reassemble the creative work, the textual, the visual, the oral. In some cases, even the tactile. You might have an interactive experience where you would have tactile feedback from worn elements, let's say gloves or worn pieces or vibrations, and then the user could redesign the experience so that it's aligned with the sensations that they would like to experience in that visit or exploration for a collection. Now, the activity we're going to do together is one of the advances that facilitated the development of extended reality experiences. So we'll start with 360 videos and how that changed how audiences experience art, but also how audiences can be pulled into artistic creations. So if we look at that, we are going to take a look at a few examples before we actually visit a collection together. So let's start in thinking about augmented reality, and it is one of the 4 types that we'll look at together in the second part of the workshop. So with augmented reality, it's having digital objects or digital designs overlaid in the physical world, so you can actually see and explore and move around with a device, whether it's a tablet or a mobile phone, and then see these objects that present more visuals or more elements to the physical space that you would be in. So imagine using the mobile phone to either look at a collection that's already created, or some objects could be pulled into the space that you are actually in. So you can visit virtual spaces, or you can have these spaces come to you. Another experience would be virtual reality, and that is where you are transported to a virtual space in which collections or artwork is being showcased and displayed. And this is one example of the Google Art example. This is the Sao Paulo in Brazil museum, in which you can explore different pieces as you virtually move around the space. Another example are the digital assets and the level, the high resolution that they can be displayed in. A few years back, it was limited to the bandwidth that we had and the computational power of the machines that are available in the consumer product market, from mobile devices to laptops or desktop machines. At the moment, we're seeing high resolution images being rendered in a very simple or a typical laptop, an average laptop. So one collection is the collection that we have in this museum in Peking, Beijing, in which the high resolution of the artifacts could be explored by the visitors. In some cases, we do have virtuality vary. You might have a full exploration of the physical space with the artifacts zooming in, either in augmented form or simply layers of screens, or in other cases, it might be a walkthrough. And you would have layers of information available where you can click and explore. So some cases are digital copies of real works of art, and others are artworks that are created in the digital realm. So it doesn't really exist in the physical world. It doesn't have a physical embodiment. However, users are, or audiences are invited to explore such realms. Or collections. Another way to look at it, if it's viewed in 2D or experienced in 3 dimensions, and that's something we'll dive deeper in the second part of the workshop, because when we look at the transition in graphic user interface, for the past 3 decades, designers and developers have been mainly, or the mainstream applications were for mobile applications or mainly screen applications, and that's 2D environments on a 2D space, or 3D environments rendered on a flat 2D surface. However, right now, with extended reality technologies, we have the opportunity to have the audience or the visitor or the user actually immersed in a 3D world. So we're designing for a 360-degree or 3D space in which all angles need to be designed, made available for the user, so that if they turn right or left, that also is aligned with what they see in the screen or on their devices. Now let me make sure that we're also aligned with the slide. We're on slide 21. Okay, so the audience and the artists, curators, auctioneers also have increased their digital footprint. We can see from the emerging technologies and what is being introduced to audiences is the experience of the visit, but also the experience of creating it or even adapting it in some of the creation. So it is no longer a one-way bandwidth, it's a two-way interaction mode between the creators and the audiences. Now, I'm sorry, go ahead.
Sorry, I thought I was muted. My Zoom crashed, sorry about that.
Oh, no worries, no worries. All right, so the activity, let's do this activity together. So I'm sure that with everyone with us here in the, virtually in the Zoom, we do have around 20 plus. So we're going to visit one of the art museums in Estonia that did an amazing job in the 360 rendering of their exhibits. We're going to visit one exhibit in particular with 360 video. It means that it was captured so that the full view of the space is captured and made available to the users. And we have seen that in videos that are displayed on our mobile devices, laptops, in which you can have a full 360 view, even if you're not wearing any head-mounted display. So this is one example. If we look at the exhibit, we're going to visit one specific exhibit together, and I can conduct the walkthrough on my machine, but let me share the link with all of you. And yeah, so this is an exhibit. It's called Violence Grows in Silence. Let me just share the link here. Okay, so I'll be sharing the link on the chat. Let's see if it works. Yeah, once you click the link, let me see if okay, I'm switching my screen. Now, if you visit the exhibit, you can, okay, it's rendering slow, but let me guide you. If your machine is faster, it's perhaps the bandwidth. I will show you the two fixed screens. So with the link, you will find an exhibit that's listed as Violence Grows in Silence. We could spend 5 minutes in looking at the exhibit. The concept is highlighting domestic violence, and it was basically presented to users in the physical space as a collection of dead plants that were donated by the community that came together in this exhibit. And you would have to navigate. It was intentionally made difficult to navigate in the physical world. So when you explore the space, you have these points, the white points, in which you can turn right and left, and then there's a flight of stairs. So if you had access now to the exhibit, I would encourage you to navigate between the trees and then go up the stairs, and what you will find virtual avatars seated watching the video that highlights the voices of individuals that describe their experience of domestic violence. So it was building up, it was designed to build the experience so that whether the visitors, the audience, were on site in the museum or visiting the virtual exhibit, they would experience that complexity navigation first, and then they would have access to the video that attracts and sustains their attention as they watch the experience. All right, so let me give you a few minutes and see if you manage to find the exhibit and explore it on your own, I don't want to rush through here so that we give everyone a chance to take a look at the exhibit. And I see a question in the chat. We'll get to that in a moment. Let me share a direct link to the exhibit if you did not find it from the main screen. Now let me do a quick check. If you are visiting the exhibit, give us a thumbs up or any comment in the chat just to make sure everyone's following.
Professor, I just want to say that if you click on the link and then you click continue, I think it'll let you, it appears in the middle of your screen. That'll let you navigate through everything.
All right, yeah, thank you. So I'm at the point where I'm walking up the stairs. Let me make sure that the Zoom screen is also showing this, yes. So as you go up the stairs, you have access to the video that's showing, and then you can see the heads of the virtual viewers that are also embedded in this experience. All right, so I'll be switching back screens. I'll turn the screen off, and I'll be jumping back to the slides to give everyone a chance to experience it. I can provide a little bit of commentary as you are experiencing this exhibit. Keep note of the videos, because once we look at reality engines, we'll look at how these digital assets basically are created. They could be built from scratch, or they could be video capture. So much of what you see in this exhibit is realistic, so it's real video. However, you do have assets embedded virtual to create that experience for the users. So the experience here is that once you enter the big hall, the visitor is confronted with a work that prevents you from wandering around. So it does block the easy access. The plants were placed there for a specific reason, so that they're spread over the floor and you encounter these plants that are barely alive and mostly dead. And it's often, basically an expression of how these domestic environments would be, in that they lack the nurture and care that is needed for these plants to grow and be lively. So the accumulation of plants would introduce you to the show that is accessed once you climb the stairs. All right. Now, the underlying methodology, the artist here is Flo Casaru. Her artistic practice is abstracting and then recontextualizing the everyday objects that we see here, from the plants and the items that are often found in households. So the artist wittily changes the meaning in order to formulate a social critique, and in this case, the topic of domestic violence. All right, now let me jump to the question that I see in the chat from Tass. What are good digital software to create digital art? We are going to look at that in the reality engines, because with every engine, it is often in the tech stack compatible with digital art platforms, and we'll go through that in a moment. All right, so mainly we're zooming into Unity and Unreal. So let me do a quick check with everyone that is participating. If we're good to go, we can move on to the next topic. Let me make sure, Isha, just to make sure that we're on the transition slide of what is extended reality, which is on point with the question that was presented.
Yes, we are. Thank you.
Wonderful, wonderful. Okay, well, thank you so much for that. With the activity, I'm hoping you got an insight into the type of medium that could be presented to users. And keep in mind, you experience this with a flat screen, whether you're following this workshop on a mobile device or on a laptop. However, the experience would be much different if it's a purely virtual world and you are transported with a head-mounted display to the experience in which you can hear, see, sometimes touch and taste and feel some interactions that add realism to the experience. All right, we'll start with a few definitions. Now, what we looked at a few moments ago are different examples of augmented and virtual reality. And what we have is basically the three basic types, where augmented reality is the real world and the virtual elements are overlaid in the space or environment that we are in physically. In a virtual world, the user is immersed into a virtual space in which the digital objects could be realistic. So realism could be achieved with the design of such environments, or they would be designed to actually present the illusion of being transported to a different world that is far from what we experience in the physical world that we live in. So it's a virtual immersion into a simulation, and it could be designed in different ways for all senses: the visual, the auditory, tactile, and in some cases olfaction, and that's the sense of smell. Mixed reality is we have a combination of both. So you would have semi-transparent, so the headset does not block your view from the physical space that you're in. And then you also have the digital objects overlaid in this physical space. The difference here is that you can interact with these virtual objects. And an example would be if I had a cup of coffee and it is a virtual mug in a physical space. So when I place the mug on a table, the physical table, the laws of physics apply and the mug would be resting on the table. The virtual mug would be resting on the physical table. That's just one example of how mixed reality can combine the features of different objects and blend them together in the way we interact, move, or push and pull, or all the affordances that we have in human-computer interaction. Okay. So the continuum is one of the basic concepts that we always introduce to designers and developers so that we understand in which realm we're designing and developing. So we often move from experiences of what we know as the real environment to either augmented reality, and that's adding virtual objects to the physical space, augmented reality or augmented virtual reality, where you have real objects projected and controlled in a virtual world, and that's where mixed reality is often best fit. And then you have the virtual reality, where the user is transported to the virtual space or the virtual world. Now, the emergence of these type of technologies was mainly in the past 5 to 6 years. So from 2014, we have seen the immersive and extended technologies advance and become more mainstream because of the advances in hardware and software that made it possible to have the streams of data transmitted to the user, individual user, so that they can experience it, experience virtual worlds, and also it caters to multiple senses where the technologies sensor-based technologies were not advanced at that time to be integrated with the headsets more than a decade back. So when we look at the different technologies, how they came together was mainly 5 years ago, where we saw the streamlined compatibility cross-device in which you can design a software, develop the code for designing an experience and simply plug in the different sensors, plug in different platforms or connect to different platforms, and then deploy in a seamless experience for users. One example that we just experienced in the activity was a 360 video. So you can actually have a full view. You're not limited to the field of view of what we see on a flat screen, so that the media in itself in the virtual world, it's either designed with 360 or actually captured. So if it's a realistic experience, then the video is actually captured in that way. You can design a VR environment, and that's the virtual world, the 3D environment in which people can walk, manipulate objects, and move and interact with others. The interaction with others raises the complexity to the next level. So if there is human-to-human interaction in the virtual world, where it's not with an avatar, then it adds complexity, and many of the computer science or the HCI problems are still unsolved here in terms of conversation design and also interaction, because humans with objects, we know the laws of physics and how to interact with these objects, what to hold, what to place, what's the affordance of these objects. But when it comes to human interaction, it's difficult for machines to anticipate. And this is where AI comes in, of what a person can be doing, can be saying, what to capture, and how to design for that type of interaction. In augmented reality, 3D content is overlaid, and we have seen that early on from the Pokemon game that introduced it to the mainstream, to more advanced experiences that we're seeing now. Now we do have, yes, a 360 video in which you can experience it. This is the second activity. So let me have, it's bit.ly SAAI video. Let me share that also in the chat. Here we go. It's a shortened video in which, because the experience that you see here in the video that I'm showing will be different when you experience it on your own device. So to make it easier for you to choose and explore, so choose your own experience. You can look at any direction. So I'll be turning to the right. So of course, this isn't, this isn't a realistic experience, it's rendered. But if you visit the video itself, yep, you can explore the sky, you can look at different directions, because the virtual space was designed to allow for such navigation. Of course, it's muted here so that you all get the experience of listening to the audio on your side and also exploring the video. Now you can imagine how these virtual worlds or virtual spaces could be created if you do have an artist, a creative work in mind in which you want to invite the audience in. It could be abstract, it could be realism. We'll also look at the tension between realism and abstract or simplified designs, because realism is very expensive in terms of computational power, and that's a design decision that artists would make. More examples here are in this website. So it's artsandculture.google. You can take a look at more 360 videos. So I think we're going to go through a quick interactive quiz, but before we do that, let's take a look at how XR adoption has been observed. Basically, in the context of art, we've seen it in museums showing their curated collections, and in artistic expression, in which the artwork is basically created in the digital medium and shared with users. The tools, this is to answer Tas's question that was posted a few moments ago. So there are the 3D modeling tools that are well known in the design community, such as Maya and Blender and others, but also there are tools in which you can create in VR, because that eliminates the complexity of designing 3D on a 2D or flat surface. So stepping into the virtual environment allows you to focus on the creation itself rather than the technical side of designing 3D. So the tools that we are looking at here are just a few examples of many that have been introduced to facilitate the creation of 3D art without the knowledge or understanding of how 3D modeling works. So it eliminates the learning curve or the barrier to entry to such creations. One example is TiltBrush, and you can visit tiltbrush.com and we'll look at both TiltBrush and Quill. Let me make sure here that this is muted. So what you see here is an example of how TiltBrush was introduced to artists. This was the Google Cultural Institute, and it was introduced to the artists to see their first impression in that tool and how that could facilitate their process in creating digital art. And what we have seen, or what research has shown, is that once the artist steps into the virtual world, the creation process becomes more of the focus on the creation itself rather than tweaking the technical details to have it aligned with their vision, or addressing the glitches or the limitations that the platform presents to them. And this is where the creation was taken to the next level. And as you can see from this video and many more, if you search online to feedback on TiltBrush, in that it did facilitate not only the creation, but also for them to reflect and tweak it in a much easier way. For any of the audience members who are familiar with 3D modeling and graphics, it's a tedious process in which tweaking the images would require some technical background, in some case, some mathematical modeling. Another example is Quill. It's a VR illustration animation tool, and you can see here again the video is running, and I'll just briefly describe how this tool also helps with creation animation. You can create the assets and then you animate them, you create the scene, so you do have this visual world created, and it can be deployed either on flat screens 2D, so it appears 3D on a flat screen, or deployed onto HMDs, and these are the head-mounted display in which the virtual world and the objects inside this world, in what we refer to as assets, are merged into a virtual experience, and the user or the audience is invited to enter this virtual world, and they can actually experience it in whatever the designer created. And what they see, what they hear, and sometimes the wind blowing or what they feel in terms of tactile could all be embedded in such experiences. So this is another example. The tool is designed to be expressive and also precise in the way the animation is designed. Once the navigation and the type of manipulation is identified, it just becomes a matter of running the code and deploying on the device, whether it's flat screen or 3D immersive experience. All right, so now we're transitioning to the engines. What we saw are the platforms or tools that could help designers either capture realistic views, and that was the example of the 360 videos, or help you as artists or creators to look at how to create assets or digital assets. And these are the objects that could be embedded in the virtual world, or could be actually the work of art that the audience would be invited to explore in the virtual realm. Yes, so before we look at the engines, a quick quiz. So we're going to go through the mapping. I just want to make sure that the audience here is following in terms of mapping the types of XR in extended reality. So if we look at this popular overlay that Jeff Koons created, so the sculptures by this artist were made available to audiences that are geographically in close proximity to some monuments across the world. We had Central Park in New York, Sydney Opera House in Australia, and the Eiffel Tower in Paris. So with this experience, the question is, what type of XR do you think the sculptures here would be mapped to? Is this virtual, augmented, or mixed reality? So the question is it VR, AR, or MR? You can type in your answer in the chat window. Okay, I don't see any response in the chat window. Thank you, Michael. So one answer is augmented reality. The concept here, yes. Okay, so I'm seeing 2 responses and both of you are correct. It is AR. In that the sculptures were overlaid over the scene. So a person can take a photo or a video and capture that a augmented reality. Now take a look at this music video in which what you have here is you're listening to music, but you're also being transformed into a virtual space in which you are looking at different objects and also other people that are wearing head-mounted displays and listening to the music. Let me see if I can share the audio here. Okay, so you can watch the video in full. You can look up Square Pusher, but in this example, what type of extended reality did the Square Pusher team use in the music video? Now, of course, none of you were wearing the head-mounted display. It was displayed again on a flat screen. But do you think it's VR, AR, or MR? Thank you, Julia. So one answer is VR, MR. So Arnab, it could be MR if the digital objects are overlaid in the physical world. I'm not sure this video actually implements that, but if it had that added feature, then it would fit with mixed reality. But it's closer to VR as noted here by Julia and Michael. Thank you all for the response. So mixed reality is just a version above in that a level above in terms of implementation, and that the virtual experience is also it also involves that the digital objects exist in the physical synthetic world. So the head-mounted display is often semi-transparent rather than having it transparent or blocked. Okay, so here's another example. Acute Art created these objects that could be projected in the context of where the person launched the application, whether they're in public spaces, at home. So it showcases works from artist studios and it's displayed by the user's personal device. So again, what type of XR did Acute Art use in that example? Quick question. So is this virtual augmented reality? So virtual means you took the user and transported them to a virtual space. Augmented, you brought the digital objects to the physical space of the audience. Mixed reality, you have a combination of both. There is the virtual world, but you also have the physical space intact, and you can interact in that the digital objects interact with the physical world. All right, so the work here is Acute Art. You can actually visit the website's app. Let me copy the link. It's app.acuteart.com. It is closer to MR if you actually had the headset, or AR. So yes, it is actually AR. It's augmented reality. Now, if someone is wearing a headset, however, on their website, they did not make it, they didn't disclose if it's made available on mixed reality headsets such as Magic Leap or HoloLens, but it is closer to AR. All right, now that we have these three terms clear, we will be jumping into the topic of reality engines. But what we saw here were three examples in this quick quiz, and thank you all for taking part. We looked at how the different types of extended reality actually expand the scope of what an artist could create and make available to different audiences. It also expands the scope of what audiences could do in the digital realm, whether they step into it fully, as we saw in the virtual reality, or they actually bring in the artworks in their synthetic world. And that's what we saw in the mixed reality or augmented reality. So we're seeing this, the advances in XR making the artwork more accessible, but also the interaction design that was not feasible a decade ago right now, very much seamless when users are transported to these art experiences or creations. All right, so the advances, we don't see it slowing down. This is just the industry before we look into the technical details, because what we are seeing is that the community is growing, the technology is becoming more accessible. It is driven mainly by the gaming industry, interestingly, because of the massive market that the gaming industry has in terms of the immersive experiences for gamers, and much of that has been applied to different contexts in training, learning, and in this context, artistic creation. So we do see that as an advantage, and the virtual spaces are becoming more creative, and we're seeing different experiences being captured, from volumetric capture to the different audio capture and how that is rendered, as we see here with the SAAI, the AI-enabled or AI-driven technologies in the way the capture is optimized, but also the rendering of such experiences is becoming more streamlined. So this is a prediction to what could also be made available, or what is the projection that we see in terms of the platforms that we just took a quick look at. You can see that the experience of how audiences see art or touch art or experience art would be elevated, in that they can see, hear, without having the limitation or the constraint of being in the physical space, allows them to explore it in their own way, or also gather information in a more streamlined way. From the artist's perspective, they can expand what could be created in the digital world to create different experiences with an object that they envisioned. And we're going to see that in a few moments in the reality engines. All right, so with that, we will go for a very short break, 5 minutes. And I see that we have less than 20 participants. So let me ask you this. Do you want to take a 5-minute break, or power through to the second part of the workshop? All right, if I don't get a response, so let me go ahead and go through a 5-minute break. All right, just a quick break for refreshments or if you need to stretch, and then we'll come back for the reality engines and the learning resources so that if it's a platform you'd like to consider, you can explore it at your own pace. We can do a 3-minute break, so let me do this. Okay, so 3-minute break. Thank you, Arnav. All right, welcome back, everyone. This is the second part of the workshop, and this is a bit more technical. What we looked at in the first part were the types of extended reality technologies, and we experienced a few of the examples for 360 videos, and also we looked at some of the tools that artists or creators could consider in virtual spaces or designing virtual worlds. So what we are going to do here is a quick recap, and then we'll look at the leading reality engines. So to recap, the types of XR technologies that we talked about and saw examples of were augmented reality. And this is where the reality is enhanced by having virtual elements in our synthetic world. Virtual reality is the other end of the spectrum, in which the audience is transported to the virtual space. It's fully digital, so you have the assets and you have the spaces designed so that the user or the audience is immersed in that environment. Mixed reality is in the middle. Basically, you have the physical and the synthetic objects coexisting, and you would apply the features of the virtual objects to the synthetic elements that you have in your environment. But you can also enhance the experience for users in that the semi-transparent headsets that they would have could also overlay information that's relevant to the experience in whatever way you would design. So having a look at now the types of technologies that could be designed, we look at the reality engines, because the idea is that reality engines are basically the platforms in which you can create assets, whether within the engine or import them from other 3D modeling platforms. And there are many out there. Maya, Blender are just two examples, and there are many more. And many of the reality platforms are compatible with these mainstream or well-known 3D modeling platforms. And then you would create the virtual world and design the experience. That's the third layer, because the interaction design is where the complexity lies in what are you designing for the users to be able to interact, how will they interact, what will be manipulated. So these features need to be designed and developed. Unity and Unreal are two well-known platforms for such creations. Unity is more technical. It's easier in terms of barrier to entry, more popular with the coders when compared to the artists, in which the preference would be Unreal. However, the barrier to entry in Unreal is a bit higher in terms of the graphics development. However, the quality is different, and we'll look at them side by side in a bit. So the key features that are relevant to artists that might be considering these tools, and also to answer the question from Tess when you were asking about what are the tools, Unity and Unreal, that we're seeing together with the tools that they have in these platforms would be the answer to your question. So with Unity, we're looking at AI-enabled features in materials themselves and selection of the material, having the realism designed and developed for the audiences requires some intelligence in what is embedded in the scene, the placement, how do you make it visible to the users, how do users interact with it, and also if there are sensory inputs or elements to the design in what they see, what they hear, what they touch, then that needs to be taken into consideration as well. So the tool or the feature within Unity is the art engine. It's AI-assisted artistry, basically automates the process so that the artists focus on the creation rather than building the algorithms or the modeling for such objects or such interactions. And this is where you can explore it under the product collection of Unity. And it basically, it has some coding involved. However, it is mainly a user interface in which click, drag and drop, set the features, and you can start creating the virtual space that you envision in your mind right away. So that's the art engine. The process for that, let me make sure the video is rolling. And Isha, do let me know if the screen is not showing the video. Here it is. So basically,
it's good.
Thank you. Thank you so much. So with the art engine, it goes through a process in that objects could be designed from scratch, embedded, or imported from other libraries. And the marketplace for assets are plenty. Each platform has its own community, own marketplace. So you can look up marketplace for digital assets that are compatible with Unity, or you simply scan the world. So the example of 360 videos that we started with was relevant because I wanted the participants in this workshop to experience how the actual physical world could be captured and visualized within the space. And then users or audiences are invited to join those virtual spaces. So in terms of data in the art engine, you can have a search for the data, scan, paint, and then it goes through the automation You can enhance it, you can expand, you can transmit. And what happens is that when users manipulate the creation, their experience in that space might be very different from another person that entered that virtual world. So this individualized experience, or the bespoke experience, allows users to take the experience to the level where curiosity would lead them to a different experience in every visit, in every interaction with that object. And that is the beauty of extended reality, in that that experience could be captured. And not only that, the objective measures of what a person sees, feels, even the heartbeat, or if you have the right sensors, the anxiety level, the user's emotion could be inferred from what you see. You would have eye tracking, you can see their eyes, or you can see through their eyes, and the heat maps of what they see, what they touch, how they interact. And that rich data set could also be captured, exported, and looped back in, designing the experience in a different way the next time that they visit that virtual space.
When you're creating content
Now,
in Unity, you can
let
typically
me
see
mute this as well. Another concern that we all often have is the barrier to entry is sometimes the hardware. So do we have a simulator? And these both platforms have simulators. So Unity allows the developers to actually explore it on a simulator, design a virtual world, and then explore it before it's deployed on a head-mounted display. So it does facilitate that type of testing, user testing before deployment. Now, the resources available, both of them have excellent libraries and learning paths from beginner, intermediate to advanced. And with Unity, they have a specific learning path for VR, AR, MR. So even if you are beginning in exploring this medium, it is something that could be mastered in 2 to 3 weeks in terms of the basic usage and deployment. So you can go from a digital creation to a deployed product in 2 to 3 weeks using Unity. It's free, accessible, and the learning path walks you through a project. So it's project-based learning. Unreal. Okay, so the next engine that is well known in the field is Unreal. Now, Unreal is optimized for extended reality. It is much more powerful. It's usually used by gaming studios and also in the film industry, or even high resolution creations in terms of audio, video, in installations or concerts. So it is optimized for extended reality. There is some fees, not all of it is as accessible as Unity is. You can explore what is available under Unreal through the unrealengine.com website. I'm just going to zoom into 2 features that might be relevant for the SAAI, and there's a wealth of information on their website. So one feature is geodata, so geospatial data. So if you have an experience in mind in which space or spatial interaction is relevant, then it does have seamless integration with these tools, as you can see here featured on the screen, and its strength here in MetaHumans. So creating human-like figures is something in the pipeline, in the XR creation pipeline with Unreal is just a matter of minutes in creating features and manipulating the features from different ages, different skin colors or ethnicities. It is realistic. So in terms of realism, very high, where it can be achieved in Unity, however, would require much more effort to achieve the humanoids or the human avatars. So if this is something that you are aiming to consider, then Unreal would be a more a viable option in terms of platform to develop a realistic experience. All right, so the learning resources similar to Unity, you have the design assets and spaces all available in terms of the pathways, the learning pathways. You can look at how you design 3D objects or model them, and then how do you create assets, embed them in your virtual spaces. and also looking at the design of virtual spaces, the lighting and all that goes, all the design aspects that go into what the user will be doing in these spaces, how they navigate, what are the affordances, what can they touch, what can they manipulate, and the interaction between different users, which adds complexity, but if that is part of the experience, then it can be designed and considered in your creation. Now, going back to the tension that is well known between realism and abstract drawings, simplified drawings, just so that the user is immersed in a virtual world, but it could be very realistic, and that comes with the computation complexity, or you can simplify the images because the experience offers different aspects, whether it's auditory or tactile senses, or even the visual would suffice in the way it is designed. It's a design decision, and many of the platforms afford both. So it usually depends on the context and the bandwidth that you have, the headsets or the hardware that is available to users. So Tess, I hope by now we have answered your question. In terms of the coding, this is the final platform in which with OpenXR, it's basically an augmented or virtual reality platform. It's a standard for developing for these platforms. And you can access OpenXR if you look at the Kronos Group Consortium and their resources. And what I wanted to highlight here is how OpenXR fits into the tech stack that we have in terms of different reality engines. So if you are using Unity, Unreal, or any other proprietary engine, and you are connecting, what you find is that with OpenXR is the application interface in which you can design a virtual experience, a virtual world, virtual assets, embed them, design the interaction with a vendor agnostic approach. And then you deploy basically on the headset. Sometimes it would require some tweaking, some libraries that are specific to that vendor. However, the OpenXR creates the standard that makes it much easier in terms of a cross-device type of design where you're designing one experience, but also deploying on multiple headsets. All right, so as a recap, this is what I promised you to reflect on before we move on to the use cases. And that is to take a look at the two options that could be considered for extended reality. If we have them side by side with pros and cons, we have Unreal and then Unity, and 5 different aspects in which we can compare them. The quality of the graphics, as I mentioned earlier, coders prefer Unity. It is known in the community, while others, artists, especially if they're tech savvy, are probably more in the first group. However, artists that have less exposure to different technology or coding would prefer Unreal because the barrier to entry there is much lower. The visuals are much quicker to render and deploy with Unreal. The material editor that we saw in Unreal and the AI-driven approach to creating these objects make it much easier. This does not mean that it can't be done in Unity. However, it does require more work to achieve it in Unity. You can also embed the Maya Blender products or any other platform. They're usually compatible with both Unreal and Unity. Now, in terms of features, AI and how well it is implemented, it is very much prevalent in Unreal Engine features when compared to Unity. Again, having said that, with Unity, you can have AI-driven models as part of the experience. Unity serves more of a user interface type of design, and then once you deploy, you can plug in the AI-driven modules. Target audience, Unity is popular among the independent developers, the indie community. Unreal is more aligned with the big studios, the gaming studios. However, the independent developers of extended reality experiences are embracing Unreal more and more these days. Now, in terms of coding, C is mainly C# is the language that is you deploy in Unity, with C++ being linked to Unreal, and this is one of the reasons where it's easier to find seasoned Unity developers when we compare it to the Unreal Engine. However, if you're in the tech community, in many cases, they're familiar with both languages. Now, in code editors, both of them have visual code editors. In some cases, it can plug into with the tech stack to other scripts that could be embedded in the objects, could be embedded in the interaction design. Community, both of them have thriving communities, so they're comparable in that regard. Okay, final check. I don't think that we would need another break, but we can break for 5 minutes if time allows. Yeah, I think if we can skip the break, would it be okay with everyone looking at the chat window to power through? We have a few use cases.
I think that's okay. I think we can continue.
Continue, okay. Thank you so much, Isha. All right, so extended reality at the intersection of AI and art, which is what we are experiencing with the SAAI hackathon or the SAAI factory. And to spark the interest in considering extended reality or experimenting with these platforms, we're going to share with you a few use cases in all 4 categories: motion capture, language, picture, still images, and audio. Now, AI, how does it link to AI? As I mentioned before, with the sensors that we have, these headsets and these experiences, you can measure what people see, what they hear, tactile. And in addition to that, you can give the feedback to vibrations, let's say with tactile or motion senses, olfactory senses. They can hear when the oral architecture is designed, they can hear in 3D versus also not versus, but also enhancing the experience with just experiencing on a flat screen with their eyes the virtual space. So we are going to look at a few use cases that have a dual mission. They are, in these examples, they preserve and investigate art and medium and how that can be presented to the public for a specific purpose, whether it is to introduce art to a community that is not aware of it, so it's raising awareness, or to allow to make the art more accessible and allow users to manipulate part of the experiences. So that they experience it differently every time, or they see it from what is aligned with their curiosity. So we'll start with motion movement, and we'll take a look at one example here, and then one project that is also participating in SAAI. So this example that you see here with asphyxia, it's a fusion of dance and motion, in which they were experimenting with the motion capture using Kinect. So it wasn't advanced mocap suits or advanced sensors. It was simple motion detection remotely, not mounted on the dancer. And these visuals were created to show how filmmaking could be done by capturing let's say incomplete information, then augmenting that with the information that would be rendered or merged and integrated in the computing side or in the virtual space. So the experience that inspired by that work, we do have traditional dance for indigenous populations or folklore dance local to the region. So we do have a team that's looking at with the Royal Institute for the Traditional Arts, the performing arts, and these are the motion that is being captured by these dance performances and recreating the experience so that users could be could have a closer look at the dance itself. And part of it is preserving these type of dances that are passed on from generation to generation, but also introducing the concept to learners who are interested or to audiences who want to learn more about the history. So we have different regions, 6 regions participating in the local hub with live performances of the dance and the engineers capturing the motion in different ways. So some with sensors, others with remote capture, and using AI-enabled algorithm to recreate these type of creations. Now, in terms of conceptualization, I wanted to share this example with Dust. It's from the group in the UK. You can visit the full exhibit from the website. It's vrdust.org.uk. It's similar in terms of the virtual reality piece. So visitors can experience the motion that is exhibited by the dancer through a headset. So it's a virtual reality headset. And let me jump to the next slide just so that you take a quick look at how it was created. So what you see here are the dancers and the motion captured remotely. So here they're not wearing the mocap suits. It's basically captured and then rendered. And basically with this exhibit, the purpose or the objective is to transform the way people see and experience contemporary dance. So it's an immersive reality experience. It explores the boundaries between virtual and the real world experience of audiences in such performance contexts, and advances research in the field of participatory performance, because you have the dancers in the space in which it's captured and the audience also in close proximity, but also it explores the human-computer interaction. How do we design the interaction in such experiences? And the VR technologies, because still with VR, we do have some challenges that are yet unsolved in terms of user experience, the motion sickness that users would experience in such visits or experiences of performance or artworks. Okay, so this we talked about image and picture. So in this, here's the example. We have one example of emotion. So emotion mirrors are basically experiences in which it can be virtual or augmented reality for passerbys. We do have walls in which the mirror would detect, the mirror would show users a reflection of them as they pass by. We have this on display on campus, and then users would be, the facial expression would be detected based on the mood, and they have emotion classification and then poetry visualized on the wall, Arabic poetry that is relevant to the emotion being captured. Now, what we're experimenting with is not only the facial expressions of passerbys, but also vocalization, not necessarily language processing, but vocalization, how words are said, or just the vocalization as people are moving across the space could indicate the emotion and the emotional status of the individual. And that's where the visualization would be with Arabic poetry aligned with those emotions. The third example for picture and image is not the still image or what's captured by video or still images of facial expressions or the audio. This is the art in the making. So basically, we have archives of more than 10 years of research in Al Qat region. It's an art form that is exhibited in the interiors of homes in one region in the southern part of Saudi Arabia, and it is delegated to the women only in those tribes, and that the males would build the structures and the interiors would be created by the females in that context. It's one of the preserved heritage or recognized heritage art forms by the UNESCO. And what we're trying to do is digitize the archives of these arts as they are made. Even the colors are made from local local plants and local. I think I'm trying to remember, so I wouldn't go into the detail here of how the color is made, but you can see here the brushes, the colors, and the full ingredients. I don't have it at the moment, but it's basically capturing the process of how the art is being created and creating an experience. What is being designed here by Leila Bafta, and she's the VR developer, are gaming experiences in which the general public could experience a walkthrough in these homes that are recreated in a realistic rendering of the home, and they can see the women in these spaces actually creating the art. So recreating the process is mainly AI driven in understanding how the art was made and recreating it by the metahuman, these humanoids that could be embedded in virtual scenes. Language text, these are the last two examples just to wrap up. I'm very cognizant of the time. With language, we have BCI, so brain-computer interfaces capture the reading of people or children with and without dyslexia, reading Arabic script. It's more to raise awareness, or this exhibit would be an immersive experience so people understand how the brains are function differently and are different for people with and without dyslexia. So it basically projects images of the Arabic script and the brain activity using EEG headsets. So these are the BCI interfaces, and it's projected in the experience where users can understand the contrast between the brain activity. So it's more of to appreciate the difference between people with and without a dyslexia, and they hear the voices of the children as they're struggling with reading these Arabic scripts as they go through the installation. Now, in music and sound, I didn't want to elaborate here because of the limitation in time, but if I would highlight one aspect that would be relevant if you are integrating audio is the oral architecture. So think about how audio is presented to users in the virtual space, and this is what we refer to as oral architecture. Recommended reading is Spaces Speak, Are We Listening? It's published by MIT Press. It's very detailed and accurate description of spaces and how we can experience spaces indoor, outdoor, and how we can design virtual environments that emulate the experiences that we actually have, from cathedrals to home environments to public open spaces and natural habitats or in nature in the outdoors. I think with that, we have reached the end of the workshop. I thank you all for your attention. And I don't know, Isha, if we do have time for questions, I'd be happy to take a few questions if time permits.
Yeah, if there are any quick questions from anyone, please, you can put them in the chat and I can relay them to the professor. Doesn't look like anybody's asking anything.
All right. We can carry on the conversation maybe on GatherTown. We have a couple of hours there.
For sure, that's
and then
exactly
we
what I was
can
going to say. Thank you so much, Professor Al-Wabil, for an incredible workshop. I'm sure everyone, including myself, benefited greatly from everything you had to share with us today. So thank you again. And yes, and with that, the second day of the SAAI Factory International Symposium has come to an end. Thank you to everyone, all our speakers and participants for making this a productive session. And just like the professor just mentioned, I'd like to encourage you all to join the GatherTown social hours. That will start from now and last for another 2 hours. And I look forward to welcoming you all again tomorrow at our final event, which will start at 11 a.m. UTC time. So please do please do note this change in time. And with that, thank you so much, everyone. And if the GatherTown link can be sent again, that would be great. Take care and goodbye.
All right, thank you.
Please send yeah, can someone send the GatherTown?